Hello everyone, how are you? Welcome to the Unity RPG tutorial. In this tutorial we're going to learn how to do 3 different moments in an RPG game. First of all, we have a very simple title scene where we're going to learn how to work with the user interface. We're going to have a town where we can use our player to navigate around this town and it collides properly with trees. And then later we can implement more towns with the usage of the tile tool. And we also can enter battles where we have our player party with a mage and a warrior. We can attack these snakes here, do some damage, okay, and basically destroy them, collect the reward, and go back to the town. It's a simple game when you quickly talk about it, but we're going to cover lots of aspects and they're going to be very interesting topics for your game development career. My name is Glaucopides. I've been working with games since 2010, and I've worked with lots of technologies like Unity, Game Maker, Unreal. I've made lots of HTML5 games, so I'm going to share that experience with you and divide this lesson into multiple topics, so we can talk about things one by one at the right pace and at the right time. Okay? So I hope you're excited to start this, and I see you soon. Alright guys, so let's start by setting up this project. First of all, we need to make a Unity project. So if you don't have Unity downloaded yet, you should install it now. Okay, just select the default options. If you want to generate builds for Android, iOS, or WebGL targets, you might want to check them as well when you are installing Unity. But anyway, to start, it is very simple. You just have to open Unity, click on this new button to start a new project, and let's fill a few things. In the project name, we're going to name this Unity RPG. And as for the location, I like to teach my students to have a good practice of creating a projects folder under their home folder. It's much better than just throwing your project in the documents or downloads folder because things tend to be messy. On the other hand, if you have a projects folder, you're going to make sure that all the games that you create are going to be here. As for how this game is going to be rendered, we're going to select the two-dimensional mode. This is just to help you by setting a few things. You could start with a 3D project and convert it to 2D normally. There will be no problems with this. But if we select 2D, we're going to save time and have lots of things already set for us. After doing this, we don't need to add any external asset packages, and we're going to create a project. So the goal of this video is to talk about what things we're going to use in this project, okay, and what external tools are going to be used, what assets are going to be used. So we're going to make sure that we already know everything that we need. Okay, so here we have an empty project, but we have a pack of assets that can be used. These assets are in a zip file that should be packed with this course. Okay, so I'm going to have this file already here. I have this art.zip. I'm simply going to copy it by right-clicking and choosing copy. And in the project, well, since we are making a Unity project, this assets folder is located somewhere in your computer. To quickly access it, you just have to right-click and choose Reveal in Finder. Okay, so we have this assets folder. Right now it's empty, but I want to make a new folder inside. I'm going to right-click, choose New Folder, and I'm going to rename this folder as Project. You're going to understand why soon. Inside the project folder, I'm going to paste the zip file with the art assets. I'm going to double click it to expand it. Okay, so you have these files here. And I'm going to get these folders inside the project folder. Then we can get rid of these art files. Okay, so move to trash. So this is how it looks. Assets folder, project folder, and then we have fonts, maps, and sprites. So if we go to Unity now, and wait a little bit for Unity to process all of these files because they have to convert to the proper format. This is what we have in our project folder. Okay, so some people might ask themselves when they're making their first projects, why do we need a project folder if we are making a project? Okay, it should be clear that everything that we are doing here is related to our game. The thing is, when you add external packages, when you add external tools, they're going to add their own files and their own folders in the root of the assets folder. So if you just put all of our folders in the assets one, if you put fonts, maps, sprites, scripts, and animations, there is a risk of you confusing what folders belong to your game and what folders are actually they actually belong to third-party companies, for example. Okay, so it's much better to do it like this because we're going to make sure that everything that we create is going to be in this project folder. Okay, so we have fonts, maps, and sprites. Since this is a two-dimensional game, there are a few things we have to care about. If you go to the sprites folder, you're going to see that we have battle, tile set, and world. Let's take a look at world right now. Okay, we have a few images here, a bat, a dragon, snake, villager. So there are some interesting images here, but one of them is a bit different than the others. If you look at player, okay, if I select player and I look in the inspector and increase this a little bit, you're going to see that this is a sprite sheet. Okay, so it's a collection of sprites. You can see the player moving down, up, left, right. You can even see the player throwing some punches here. But the thing is, you can't use this image exactly as it is right now. If you were to put this image here in the scene, you would see the entire sprite sheet, but that's not what we want. Whenever we are dealing with sprite sheets with sprite animations that look like this, we want to slice this image in smaller images. Okay, for example, maybe we just want the image of the player looking like this. Maybe we just want the image of the player throwing a punch to the right, for example. So how do we do this? Thankfully, game development has evolved a lot in the past few years, and this is super simple with Unity. We're going to select the player image, so it's going to be loaded in the inspector window. We're going to press, actually before that, we're going to look at the sprite mode. If you look at the sprite mode, it says single, so it's just one sprite, just one single image. We're going to click here and choose multiple. Okay, when we do this, we scroll down a little bit and press apply. So the information that we're going to deal with multiple images is going to be saved. And now we go to the sprite editor. And with the sprite opened here, we want to slice it. Okay, so if you click on slice, you're going to see that there are multiple types of slicing. Okay, we have automatic, grid by cell size, and grid by cell count. This is the easiest one of them, grid by cell count. So I'm going to click here, and you're going to see that we need to set a few things. We need to set the amount of columns and amount of rows. So we basically count. We have 4 columns and we have 7 rows. So 4 columns, 7 rows, and then we hit slice. It's going to be a bit difficult. Actually, yeah, we can see that. You're going to see that there are these green squares now. These are the slices that we were able to make in this player. Okay, so with that set here, we can press apply to save all of the sprites. We can close this, and if you look at the project folder now, you have the player here, and if you click on this arrow, you're going to see all of the slices that we made. Okay, all of the images that belong to the player are now here, so you can drag them individually and put them in the game. Okay, so this is basically what we need to put these sprites. We have to do some slices in other places here as well. So just so we don't do that on multiple lessons, we can do everything that's going to be needed right now. So we're going to the battle folder. Okay, so let's check the sprites that we have here. We want to deal with these icons. We're going to use these in the battle scene. So I'm going to select this icons image, sprite mode, multiple, apply, and then we sprite editor. We need to count. We have 10 columns and 4 rows, so we're going to slice. This is going to be 10 columns and 4 rows, slice, and then we have the squares properly set here. Once we apply, all the sprites are going to be saved. And if you expand the icon, you're going to see that every icon that we have here has been separated. So you see, it's a good system. It's much better to do this because you don't have to include hundreds of images. You just have a sprite sheet and you just slice it and use it inside Unity. Okay, we're going to need to use the mage as well. So sprite mode multiple. We can even press sprite editor and press apply here. So we have 5 columns and 4 rows. 5 columns, 4 rows, slice. We're going to apply. So every time you do this, you might want to check if it looks good. Okay, apparently it looks okay. We're also going to need the snake. So we set it as multiple. Sprite editor, apply before we edit. Then we have 5 by 4 again, slice, 5 by 4, we press slice, and then we press apply. Okay, and finally we just need the warrior now. So select the warrior. This is 5 by 4 once again. So before that, by the way, we put it on multiple, sprite editor, apply, okay, slice 5 by 4, great. We press the slice button and everything should be good now. Press apply and there we go. All right, so this is all the setup that we need to our sprites. You notice that there are other sprites here. We have a slime, we have a reptile, we have multiple enemies here. We have bats and dinos. But since we're not going to use them in this tutorial, we're going to leave it to you to edit these sprites and use them later. You're going to see that it's going to be very easy to integrate new enemies in this project. Okay, so this is what we need to use these assets. And by the way, these assets, they belong to this author here. So it was made by Pixel Boy and it belongs to this Superpowers asset packs. You don't have to worry about using these assets and worry about copyright or things like that because all of these assets are released under this license. Creative Commons 0. That means it's public domain. You can use it freely, you can use it on personal projects, commercial projects, and there are lots of interesting asset packs here. So if you're interested in making other games and using other assets, you can just go to this page here, okay? github.com/sparklinglabs/superpowers asset packs, okay? So good, we already know everything we need to prepare about our assets, but what about this tile set image? What exactly is this? It's kind of like a sprite sheet, but these are tiles. You're going to see that there's a small unit here, a small square, that can be used with all of these assets here. Okay, so we're going to build a map by using tiles. We already have a prepared map here, but we need to use these tiles, and if you want to build other maps, you can just build them with these images that we have here. Okay, but what exactly do we need to convert all of these tiles into a map? If you look at the maps folder, there are going to be two TMX files. Okay, these files are the actual maps, but they are text files. So how exactly are we going to tell Unity by using text that we are building a map, and at a certain place there's going to be grass, at another place there's going to be a fountain? How exactly do we do this? First of all, we need a tool called Tile. It is a fantastic tool. It's a classical tool, and it works very, very great. Okay, so you just have to go to this page, mapeditor.org, and then you download the proper version for this project. Okay, and remember to support these tools if you want, if you are able to, because they're just great and they're free to download. Okay, so it's very important for us to support all of these authors. Okay, so you have to download this tool, install on your computer, and once you do that, you're going to have this project here. Okay, you're going to have tiled. So if you want to open this, once you have tiled installed, you just double click on town, for example, and it's going to open like this. This is the map that was already built, okay, for this specific tutorial, so you can use it in this project. Okay, so this is what we have for tiled. But also we need another tool. This is just a tiled project, but if we want to use that project in Unity, we're going to need tiled to Unity. Okay, once again, it's a free tool. We can use it as we want, but it's very important for us to support the authors. So go to this page, seanba.com/tiled to Unity, and you're going to be able to download this tool, okay, made by Sean Barton. So another great tool. It's very straightforward to use, but there are some things we need to be careful about here. Okay, so we have these maps. In Unity, we can just drag the map and drop them in the hierarchy like we do with images, or in this scene, for example. We need to have the tool installed in your computer, and you also need the tool files in Unity. So we're going to open Tile to Unity. This is the Mac version, but there are Windows versions as well. And at the top of this tool, we're going to click on Help and press Import Unity Package to Project. Once we do this, this window is going to open in Unity. It's a regular import package tool. Okay, we're going to have multiple folders here. It doesn't really matter what exactly we have here, but once we press import, all of the files are going to be extracted and added to your project. So once this compilation is done, you can look at the assets folder, and you're now going to have two folders. You're going to have project and then tiled to Unity. That's why it's important to have this project folder here. Okay, so there we go. Assets folder, we have project and tile to Unity. And notice again that tile to Unity has its own files here. We have materials, meshes, prefabs, scripts. It has its own thing to make it work completely. Okay. So, alright, so how do we integrate these maps here? If you go to Tile to Unity, you are able to select the TMX file and then tell where to import it to. So here in Tile to Unity, I'm going to File, Open Tile File, then I'm going to Projects, we're going to Unity RPG, Assets, Project, it's our own folder, Maps, and then we're going to select Town. We're going to press open with town selected. It's going to be properly loaded, but we're not done yet. We also have to tell where are the exported files going to. So we need to click on this export to file, okay? And once again, project, Unity RPG, assets. This time we're going to select tile to Unity, and then we choose this text file, tile to unity.export.txt. So we press open, make sure that it's going to be properly loaded here. And once we do this, if you want to make sure your tile map has been read correctly, just press preview map, so you're going to see this image. Okay, you're going to notice that these tiles, they also have squares around them. These are collision areas that have been already built in your map. Okay, if you want to change it because you're making other maps, you have to select the tile set, which is this one already loaded. You have to click here in this tool to edit these tiles. You have to make sure that you have the tile collision editor active here, so we just click on this button, and every time you choose a tile, for example this one, you're able to draw the collision area. You just click and drag around, okay? And I think you should use this tool here. Yeah, insert rectangle. If you want to add another collision area, you can just click and drag and it's going to be added. Okay. Notice that some of these tiles, they don't have collision areas, like this one here. This one doesn't have either, but it's because they're not going to be used in this tutorial. But if you want to improve, if you want to use other tiles, and if you want the player to collide with them, you have to use this editor here. Okay, but we're not going to edit anything here. No need to save. I'm just showing that to you. Okay, so we go to preview map. We can see that the map is properly loaded here. Everything's looking fine. We can see these collision areas. Once we are doing this, we have to click on big ass export button. Okay, you just click here, and if you go to Unity, you're going to see that it processed a few files. But now if you go to Tile to Unity folder and you look at prefabs, we have a town. Okay, so if I drag and drop this into the hierarchy, we have our entire town here available to be used. And if you zoom in, you can see that there are some green rectangles, some green lines, but these are just determining the collision areas. Okay, that means that if we put a player here, we're going to be able to collide with this map. Okay, but we're going to delete it for now. Okay, the good thing about this lesson is that basically we have everything set up for us art-wise and tool-wise. Okay, we have all the necessary tools, necessary files, so we can go into the next lesson and dive straight into coding. Okay, we need to make 3 different scenes in this game. So in the next lesson, we're going to work on the menu scene, right? So I see you soon. With everything set, we need to make our title scene. This is going to be a basic menu where the player is going to be able to press the play button and go to the town to find enemies and adventure into the unknown. Okay, so first of all, we need to use a canvas. If this is going to be your first time working with Unity 2D, there are going to be some new concepts that we have to introduce, but they're actually very simple. We're going to our hierarchy tab here. I'm going to right click, choose UI, and then canvas to add a canvas. The canvas is the object, is the thing that is used for drawing interface to the users. Okay, so inside the canvas we're able to quickly add images, we can add panels, we can add buttons and several other elements. Okay, so whenever you think about interfaces, you have to think about canvases. Okay, and the interesting thing about canvases is you might have lots of elements here in this game, but if you have a canvas, in general, everything that's going to be here is going to be drawn on top of the game camera. Okay, it happens like this because the HUD, okay, all the interface elements that you make, they need to be on top of the game. Okay, the player needs to be able to see the buttons, to see anchors, to see things that they can interact with. So this canvas here is going to basically show the background image. So we're going to select it, go to the inspector, and we name it to background canvas. This is the first step. Now, for the render mode, we have here screen space overlay, but we're going to use screen space camera. Okay, and once we do this, we have to specify what is going to be the camera of the canvas. It's a different way of using the canvas, but it's going to make everything easy for us. Okay, so if you do this, a new field has appeared. We have this render camera here. We're just going to select the main camera of the hierarchy and drag and drop here. Okay, so the background canvas is kind of going to adjust with the main camera. Okay, now once we do this, we also have to care about another thing. We have to take a look at the canvas scaler. This is what's going to be used to determine how your canvas is going to resize depending on the screen that you are using. It could be a constant pixel size, but it's better that it scales depending on the resolution of your device, depending on the aspect ratio. So what we should do here is click here and select Scale with Screen Size. We need a reference resolution. It's going to be the basis of the resolution that is going to be used. So for X, we're going to use 1280, and for Y, 960. Okay. And as for the other options, they can be left like this. This is basically what you need to set the canvas. Okay. And once we have this, we just need to add a background. So here inside the background canvas, we're going to right click, choose UI, and then image, and here we can add the background image. However, there are two multiple ways to make this canvas, this background image. Okay, this is the easiest of them. You just add an image and, well, basically that's it. But if you want, you can build the interface element from the ground up. We can just right click and choose create empty to add an empty game object. Let's rename this to background image. And you can add the image component here as well. You just click on add component, search for image, click here, and you're going to have an image the same way. As for the background image, we are going to our project folder right here, then sprites, then we're going to see, yeah, it's not world, it's battle. Yes, and inside battle we have this background image. Okay, so what you do is drag this image, drop it here. It's a bit difficult to see, but it's because its pixel size hasn't been set properly. To automatically resize this image, you can just go to the inspector and press Set Native Size. Okay, so this is how the background is looking like. It's fitting the entire screen. Okay, you can see it very well here, and this is where we're going to make our menus work. Okay, so this is what we need for the image. But now we need another canvas, and that canvas is basically going to be holding the title, and it's also going to hold the button. So let's make another one. Right click, UI, canvas. We're going to rename this canvas to HUD Canvas, HUD Canvas. Okay, and we're going to start by adding an image, actually a title. And even before that, we also have to change how the canvas is going to be rendered. It has to be just like the background canvas. So render mode is screen space camera. The camera is the main camera that comes bundled with the scene. So just drag and drop here once again. We change the canvas scale size. So scale with screen size, 1280, 960, and that's it. Now, to add a title text, we right click on HUD Canvas, UI, text. Once we do this, if you double click on the text, you're going to see that you can barely see the text. Okay, so you should use this tool here for 2D, two-dimensional editing. If you click, you can see things just like when you're editing images. You can resize them by just dragging these blue knobs like this. Okay, and well, you're going to be able to see text in a much better way. The thing is, because of how we have these two canvases, we have a background canvas and we have a HUD canvas, we still can't see the text. So I could write a big text line, but well, I still can't see this text. Okay, if you were to drag this element to the right, then you can see the text. So we have a few issues. It's too small. And the biggest issue of them is that this text is being rendered below the background canvas. So why this is happening? If you select the background canvas and you look at the canvas, you're going to see that the sorting layer has been set to default and the order is 0. And if you go to the HUD Canvas, it's the same thing. We have a default sorting layer and ordering layer is 0. So these two, they conflict. You can't guarantee that the HUD Canvas is going to be rendered on top of the background canvas. One way is to simply change the order in layer of this HUD Canvas to 1, and you can see the text here, or you can make another sorting layer. You can just click here on the full, select Add Sorting Layer, and here in Sorting Layers in this inspector, we can press the plus sign and add a HUD layer. Once we do this, we select the HUD canvas again and change the sorting layer to HUD. Okay, so since the HUD is below the default one in the sorting layers list, this means that HUD is rendered on the top. It's a priority over the default layer. And as you add other layers, you can change their orders and their priorities. Okay. Now that we can see this text, let's increase the size of this. If you click on any of these blue knobs and you hold the Alt or the Option button, you can resize at the same amount horizontally and vertically. Okay. The text that we want to add here is Unity RPG. Of course, we still can't see anything, so let's increase this font size to 130. So this is starting to look much better. This font is too simple, so we can change the font here in Arial by clicking on this circle and choosing this one, Kels. And one interesting thing here is you notice that this font is too big, so we just see Unity, we don't see RPG because the text couldn't fit. So we can increase this a little bit more and we can see Unity RPG. Good. As for the alignment, let's choose center horizontally and center vertically. And also move this a little bit to the top. Okay, so we're going to have our title here. It doesn't do anything special here. So what we want to add, the other thing that we want to add here is a play button. Okay, of course, if we have just this is basically nothing. So we need to go to the HUD canvas, right click, UI, and then button. Okay, you're going to see that the button is too small, so we're going to resize it the same way. We click on the blue knob, hold Alt or Option to increase the size of the button so it looks like this. We're going to move it down a little bit and we're going to choose this text here, increase its font size. The text is going to be play, and we're also going to change the font from Arial to Kels. Okay, so this is the button that we have. And if you want to test this scene to see if you can interact with this button, you can just press play. Okay, if you do that, and once the game properly loads, it's going to the game window, and you can click on the button. You can see that you even have this feedback of clicking and shading the button like this. Okay, so if you want to change the color of the button, by the way, you can just go to the button and change the color here in the image. Let's make it a bit gray. Okay, so good. However, we're close to finishing this title scene. Okay, but we need this button to do something. And what we needed to do is to change scenes. Okay, right now we are in the title scene, so we want to save this. Okay, so it's going to be used later. So we go to File, Save Scene. I'm going to name this title and press Save. And in the Assets folder, I want to move this title scene to a Scenes folder. So let's make one. In the Project folder, we're going to right-click, Create Folder. This is going to be named Scenes. And back in the Assets, I'm going to move this title scene file to the Scenes folder. Okay, good. This is the first step. Whenever we click on the play button, we are going to load another window. We're going to load basically the town scene. But when we do this, we need to make sure that the scene that we are going to load is going to be in a list. This list can be accessed by going to File, Build Settings, and there's the Scenes in Build list. You need to go on every scene that you want to add and press Add Open Scenes. So it's going to be added in this list. This means that this scene can be dynamically loaded in your game. Okay, so now that we have this title scene added here, we want to make a new empty scene. Okay, something very simple. I'm just going to File, New Scene. I'm going to File, Save Scene. I'm going to name this Town. It's just something empty. Move this town scene to the Scenes folder. And once we do this, File, Build Settings, and I'm going to click on Add Open Scenes just to make sure town is going to be here. Okay, good. Now back to the title. How do we make this play button to load that scene? So far we've been using things that were already provided by Unity, so texts, images, buttons as well, but we don't have anything super specific to do this, to load another scene. So we need to make a very short script for this. I'm going to the project folder. We're going to create a new folder here and name this scripts. Okay, we're going to double click this. Now right click, create, C# script, and I'm going to name this change scene. Okay, it's going to be a simple script like that. Once we double click this, it's going to open in MonoDevelop, which already comes bundled with Unity. Okay, it's free, it's open source, so it's going to work just fine for us. Okay, wait a few seconds and there we go. We should have our script here. And once we do this, once we have this change scene class open here, we should be able to add a new method here. Let me just zoom in a little bit. There we go. So we're not going to use the start and update methods. Even though they're used on plenty of different classes and components, we need to make our own method here. So we're going to make public void load scene, and it's going to require one parameter, which is going to be string name. The parameter is the exact name of the scene that we want to load. And to load, however, we need to include the namespace here. We can't change scenes with a default script like this one. So here at the top, we need to add using Unity Engine.scene management. This contains all of the classes, methods, and utils that we might want to use to change a scene. So now that we have this, in the load scene method, we're simply going to type scene manager.load scene and between parentheses name. Okay, so we might be thinking, okay, we are making a method like this, but how exactly are we going to call this load scene method with a specific name? Well, the trick here is that we're making this method public. So whenever you do this, okay, and whenever you serialize other things, they can be accessed by the Unity editor. So what we want to do is, we're going to select our button game object. Let's collapse a few components here to make this easier to read. I'm going to add this change scene script here. Okay, so I'm just going to drag and drop. So we have this script. And now in the button, you're going to notice that there is an on-click area, on-click panel. With this area here, we are able to list multiple methods that can be called whenever this button is clicked without having to write any complicated logic. So here in the on-click, we press the plus button. We need to select a target object, which is going to be the button itself. So I drag and drop here. And now we're going to determine what is going to be the callback. So we're going to click here. We're going to change scene. We select the load scene method that we just determined, and you're going to see that there's a field for us to pass the parameter. The parameter here is going to be town. So that means that whenever this button is clicked, this method is going to be clicked with the town parameter. And since this town is a string, it's going to be passed as a parameter here, and we should be able to load our town scene. Okay, so just by doing that, let's save. Let's also here in the scripts folder, right click, choose create, then folder. Let's name this title. So all scripts of the title scene are going to be here. I'm going to put this change scene here, just to keep things a little bit more organized. And now, save your scene. We're going to press play. Okay, and with the game loaded, whenever I press the play button, we should load the town scene. It's empty right now, but that's just as we expected. Okay, it's going to work like this for now while we don't implement other things. Okay, so this is it. This is basically the first step. It's a quick exercise on how to work with the user interface, how to make texts and buttons and work with canvases. And with this ready, we should move on to the next lesson where we're going to look a little bit more on how the RPG game is going to work. Okay, we're going to work on the player party. Alright, so even though we are in the title scene, we should care about how the player party is going to work. To make a player party work, we have to remember that all of their health points, all of their mana, experience, coins, all of these things, they have to persist over scenes. There are multiple ways to do this, but we're going to aim on a simple solution. Okay, so right here in the title scene, we're going to make a new game object. So we right click here, choose create empty. We're going to select this game object here and rename it to player party. We also want to make sure that this is going to be in the position 0, 0, 0. Okay, just for the sake of keeping things in their proper places. Okay, so we have a player party here. It's invisible. There's nothing assigned to it. So we need to make sure that this player party is going to behave differently depending on the scene they're currently at. Okay, so if we are in a title scene, then this player party is not exactly going to be used. Okay, we need to use it on other places. We need to use this player party when we are in the battle scene, for example. So we're going to be able to see our players, the mage and the knight. Okay, so to do this, we're going to need an auxiliary script for us. In the scripts folder, we're going to right click, choose create, C# script, and we're going to name this start battle. Okay, so with this script loaded here, we're going to wait for it to compile, so it's going to be properly processed. Then we're going to grab this file and drop here in the player party. And finally, we're going to double click it to make sure that this is going to be loaded. Okay, so how this is going to work? In the start method, we need to do something very specific here. We're going to call the method don't destroy on load. Okay, and the target here is going to be the own game object, the player party game object. And you can even see here in the summary that it says makes the object target not to be destroyed automatically when loading a new scene. Whenever you load a new scene, everything you have in your previous scene is going to be destroyed. It's going to be deleted from the internal memory. In a way, it's not going to well, occupy resources from your mobile phone. So it needs to do this to clean things up. But for some specific cases, we don't want this to happen. So we use this don't destroy and load method, and we type game object. Okay, this game object here is a reference to the game object that contains the start battle component. Since the start battle component is in the player party, it means the game object is going to be the player party. So this means the player party is not going to be destroyed. Okay. However, whenever the scene is loaded, whenever the scene where the player party is, we need to do something here. We need to make sure that we are going to activate or deactivate this player party. So we're going to need to be able to read what is our current scene. So we once again type using Unity engine.scene management like this. Okay, and now we need to do something here. I'm going to get rid of this update method call, and what we want to do here is type scene manager dot scene loaded plus equals on scene loaded. Okay, so what did I just do here? When we type scene manager, we are of course accessing the instance of the scene manager, okay, the thing that's managing the scenes. This scene loaded here is an event. So the scene manager is going to call this event, it's going to raise this event whenever the scene is completely loaded. It is done like this because that way multiple scripts, they can sign to this event here. So whenever it is risen, we can do something. It's like we are making the start battle to react whenever a scene loaded event is risen. So whenever a new scene has been loaded. And we're going to declare our own onSceneLoaded method here. So I'm going to type private void onSceneLoaded, and it needs exactly two parameters. The first one is scene, and I'm going to name it scene. Okay, so it's the parameter is called scene with a lowercase s, and its type is scene with an uppercase s. And we also use load scene mode. So this is the method that we're going to use. It needs to be this exact same signature, because if you hover your mouse on scene loaded, you're going to see that this event, the delegate of this event, needs a scene and a load scene mode. Okay, these two arguments here. Good. So now that we have this, we have to check what scene has been loaded. So I'm going to type if scene.name, and we're going to compare if this name, if this string, okay, if this scene is title. That's why we do this comparison here. We compare the name with the string title. And you need to make sure that this string is exactly the same name as this scene here, title. Okay? If you used another name, then you have to make sure you use the proper name here. Okay, so if this happens, if we are in the title scene, we no longer need to listen for this event. So we can type scene manager dot scene loaded minus equals on scene loaded. So this is not going to happen again. And I'm going to destroy the player party. So destroy and then game object. So it's going to destroy itself. Okay. However, else, so we do the else block. If the name is not title, we want to activate this player party if the new scene we are is called battle. So to do this in a single line, we can just type game object dot set active, and this method is basically to activate or deactivate a game object. And inside here, we have to pass true or false because it requires a Boolean value. So we can just ask here for a comparison. We can just type scene not name equals to battle. So if the scene we are currently in is battle, this is going to be true, so the player party is going to be activated. It's exactly where we want it to be. However, if this is false, it's not going to be activated. It happens in the town scene. Okay, so we leave it like this. And finally, whenever we have this start battle object called here, I'm going to type game object dot set active false. So the player party is going to start deactivated. So if you save this and go to Unity, you're going to be able to test this out. Okay, so let's wait for the code to compile. And after this is done, pay attention to how the player party is. Right now it's normal. Okay, we have this game object here. It contains the start battle script. But if we press play, notice how the hierarchy is going to change. We have this don't destroy or unload, and player party is now gray. Okay, this means it's deactivated. If you select the player party and you look at the inspector, you're going to see that it's unmarked. Okay, if it was like this, it would be activated, but it looks like this. It's deactivated. Okay, so let's move on and improve this player party a little bit more. A player party, of course, is going to need multiple players, multiple characters that are going to help you playing this game and attacking enemies, destroying them, maybe healing your teammates. So what we're going to do here is we're going to need player units. Okay, so first of all, here in player party, I'm going to right click, choose create empty, and rename this as player unit just for now. Okay, so this unit is going to require two components. First of all, we're going to use an image. So I'm going to press add component, select image, and I'm going to give it a look. Okay, so here in source image, I'm going to select this circle, and we're going to search for mage. Okay, and we can use any of the sprites of the mage that we have cut. So I'm going to use this one, okay, the simplest mage, and also set the native size. Notice, however, that you still can't see this player unit. Okay, it's invisible for now, so we have to do a little adjustment to make this work. The thing is, the way we have been using images so far is, images are components that work on canvases. Okay, so if you were to select this player unit and put it a HUD canvas, you would see that it's going to be back to normal. Okay, you can see the image now, because the image component only works inside canvases. However, the player unit is going to work as a normal game element. Okay, it's something that's going to be outside of a canvas. Remember, we have the background canvas, we have the HUD canvas, but the player party is not an interface element. It's not a HUD canvas, it's not a background canvas. It's just an empty game object in the hierarchy here. So player units, they don't use images like this. Okay, we don't need this image component, and we're not going to use a canvas renderer. What we're going to use is a sprite render. It's something that renders an image in the scene, and it doesn't require a canvas. Okay, so now that we do this, we can search for the sprite, search for mage, and we can choose the first one. So it's going to be here. Okay, we don't even have to press set native size or change the scale. It's already in the correct scale here. Okay, for the camera that we're using, for the canvases that we have adapted to this camera. Okay, this is basically our mage, and I'm going to position it here. Now, the second component that our mage is going to need, besides the sprite renderer, is going to be something that we still need to create. We're going to make a unit stat script. Okay, this is basically going to save data about the players that we're going to use. So here in the scripts folder, let's right click, create, C# script, and this is going to be named unit stats. Okay, so we hit enter, we wait for this to compile, and once it's done, we're going to double click, and we're going to add a few fields here. Okay, so let's take off start and update for now, and we're going to type public float health. This is going to store the health points. It's a floating point number, so there can be decimal values like 3.2, 1.7, or it could be whole values as well, like 3, 4, 150. And it's public, so it can be accessed. You can read and write this value, and it can be exposed in Unity, so you can check the values that we have. We do the same thing for mana, public float mana. Same thing for attack, magic, defense, and also speed. Okay, these are the values that we're going to use for now. Okay, we can already just save this, and once this is done, we can go back to Unity, and if you look at the player unit, all of these public values are going to be exposed here once you get this script and you drop here in the player unit. Okay, right now everything is set to 0, but we can already set a few values here. So for health, I'm going to use 100, mana 100, attack 100, magic, let's use 10, defense 0, and speed 10. We can change these things later as we make the game. Remember, you are in control here. These are just a few suggestions of values that can be used, but once you're done with this course, you're going to have to do your own work on tuning the game. Okay, so now that we have this, all of these settings adjusted here, I'm also going to rename this player unit to mage unit. Okay, so this is our first player. This is the first one that is going to help us achieve our goals, which is beating the enemies that we have in this scene. Okay, so now that if we press the play button, okay, you're going to see that the scene is going to load, the player party is going to be disabled, so if you press play, it's still going to be disabled. It's going to remain like this. Okay, it's going to be grayed out, and well, we're going to be able to do all of the other things that we should do. Now that we are done with this, we're going to move on to another scene. Okay, so we are done with the title for now. Let's save this scene. Okay, so we have the player party, we have the mage unit, we have the entire interface. Now we're going to move on to a different game mode. We're going to work with the town scene, where we're going to have our tiled map, and we're also going to be able to well, walk around this map and find some enemies. See you in the next lesson. Okay, so now we're going to our town scene, the one that we made that has nothing inside it. And the first thing that we want to do is to add the town. Okay, so we're going to be able to see what we exported with the tiled tool. So remember, we have to go to the Tile to Unity folder. We're going to prefabs, where our town is already completely working. Okay, it was built automatically by the tools that we used. All the colliders are in place, so we're going to be able to navigate here. So basically, we're going to get this town and drag and drop here in the hierarchy. Okay, you're going to see that the town is a bit too big because of, well, how the camera is set. So we're going to set a few values here. First of all, we want to scale it by typing 0.021 on X and the same thing on Y. So it's going to be smaller. You see that it matches much better the camera that we have here. The position on X is going to be minus 6.67. Y is going to be 5. Okay, so if you look at your main camera, okay, you can even see the camera preview. The town is going to be completely covered by our camera. And if you look at the game window, you can see the town like this. Okay, so it's fitting properly. So that's basically it. Okay, since we already covered everything related to tiled in our first lesson to talk about the tools that we need to use and to prepare ourselves to add all the assets, it's basically done. Okay, that's all we need for this town. But of course, if you press play, nothing really interesting is happening right now. Okay, we just have these assets here. By the way, it would be interesting if you made your own levels to try this out. But we need a player. Okay, the player is going to be a simple object that we can use to navigate around this scene. And with the player, we're going to be able to trigger some battles. Okay, so let's go ahead and make a very simple player. I'm going to right click in the hierarchy, choose create empty. Also, make sure you have no object selected, otherwise that game object might end up inside the camera or the town. So click on this outside area, and then once again create empty. Let's rename this guy to player. We're going to set its position to 0 and 0. Okay, so it's going to be here. You can even move it to another place if you want, like this. Okay, and this player is going to require a few components. First of all, we need a sprite render. Okay, when we add this, we need to select a sprite. So I'm going to click here, search for player, and we can use the first player sprite, okay, which is this one. Okay, so now that we have this player sprite, we also need to add a rigid body to it. And also notice that we have the same problem that we had with the text in the previous scene of the sorting layer. Okay, the town is in a certain layer, which is the default one, even though it's not specifically set here. Okay, Unity uses a default sorting layer for basically everything. So we might want to add another layer here. So in sorting layer, add sorting layer, we click here and let's add a town layer or game layer. Let's put it between default and HUD. Now we select the player again and we change the sorting layer to game. Okay, so we can see the player. It's a bit tiny. So if you want to change its size, you can scale it on 2 units. So it's going to look like this. Okay, it fits much better. And okay, that's it for the sprite renderer. This also needs a rigid body. A rigid body is basically something that adds physics to the game, but in this specific case it's just for us to verify for collisions. Remember, you have to add rigid body 2D. It's very important that you choose this one. Whenever you're working with two-dimensional games and you're going to add a component, make sure you have to verify if there is a two-dimensional version for that component, and if there is, make sure you use it. It's the case for rigid body. This is the 3D one, and we're going to use the two-dimensional one. Okay. So here we're going to change a few things, okay, to make sure collisions are going to work properly. Interpolate here is going to be set to interpolate. Collision detection is going to be continuous, and sleeping mode is start awake as it is right now. Okay. One very important change that we have to make here is gravity scale is going to be 0. This is not a game that you're going to see by the side. It's not a platformer game or a physics game. You're looking from the top down, so no gravity should be applied here. Okay, you might want to use velocity to move things in the horizontal and vertical axis, but you're never going to make this fall, so you need to make sure that gravity is set to 0. Okay, and here in constraints we also want to make sure that this object is not going to rotate, so we freeze the rotation on Z, which is the only axis that can be used in a two-dimensional game. Okay, so freeze rotation, interpolate, sleeping mode, collision detection, gravity, scale set to 0. And the final one, and very important one as well, is add component, and we use box collider 2D, which is this one. Okay, once you add it, you're going to see a little square around the player, and this square is the invisible area that is going to be used to collide with things like this tree, for example. Remember, if you click on this prefab made by the Tile to Unity tool, you see that we already see this green rectangle here. So these two rectangles, they can collide with each other, and if the player tries to move to the right too much, it's going to bump here. Okay, it's not going to be able to move past this, so collisions are going to work automatically. Okay, so let me zoom out here. Okay, so we have a very simple player. We have this collision work, but one thing that we have to do here before we make the player move is working with the player's animation. Okay, so there are two things we have to do. Make the player move, so write the code for reading the input and moving the player, but also change its animation. The animation is going to be a bit extensive, but it's actually a simple concept, so let's cover this in the next lesson. Unity's animation system makes working with two-dimensional animations and three-dimensional animations as well very easy, but we have to understand how it works. Okay, so we need to go to the project folder. We're going to make a new folder here. It's going to be named Animations, and inside it we're going to add another folder that's called Player. To make an animation, we need two different things. We need one animator and we need multiple animations, the actual animations that are going to make this player to move. Okay, so what exactly is an animator? If you go to the player here, you click add component and search for animator and add it, of course, you're going to see this component here. The animator is the state machine. It's like an internal system that it's engineered to determine what animation is going to be executed. The player and the enemies, they have multiple different animations, so there needs to be a logic to switch between them. You could do that through code easily, but it's important to understand how animators work because it's better to do things how they were supposed to do in the editor. Okay, the editor is your friend. You can easily switch animations. You can change how the speed of how animations are going to be executed here in the editor without having to deal with a lot of code. The code is needed just to do a little communication, but the actual animation can be done by its entirety here in the Unity editor. So first of all, we need an animator controller. So we need to make one here in our player folder. We right click, choose create. We're going to select animator controller, and I'm going to name this player animator, and that should be enough. Okay, so we go to the player, and I'm going to drag this player animator and drop here. Okay, so this has been bound here, so this is going to be used. And now there's something important that we need to understand. The player is going to require 8 different animations. It sounds like there are a lot of them, but it's actually pretty simple. We have idle animations and we have walking animations. In each of these, they're going to work on each of the directions that we have: left, right, up, and down. So we need idle left, idle right, idle up, and idle down, and the same thing for the walking animations. So let's make empty animations right now. I'm going to right click, choose create, then animation, and this is going to be idle left. To make this super easy to create, you can duplicate an animation by hitting Command D if you're on a Mac, or Ctrl D. So we have this. You can just rename it by hitting Enter on a Mac or F2 on Windows and name this idle right. Duplicate, rename idle up. Duplicate, rename idle down. Or you can just create one by one. We do the same thing for the walking animations. So duplicate walking left, duplicate walking right, duplicate walking up, and duplicate walking down. So all of the 8 animation files have been implemented here. They have been created actually, but we need to make them work. Okay, so first of all, if you go to the player here and you see the animator, you need to figure out how do we edit animations and the animator itself. You're going to notice that I have 2 windows already added here. We have animator and animation, but if you don't have them yet, you can just go to window and then click on animator to open that one, and you can click on animation to open the second one. So we have these 2 here. Okay, so notice that if you go to animation and you have the player selected, you notice that you can select anything. Everything is basically grayed out, so it's like it doesn't understand this player is going to have animations. If you go to the animator, you're going to see this state machine. We have this any state, you don't have to worry about this, and we have this entry point. So before we do anything else, here in the player folder, I'm going to select all of these animation files here. So select all of them, or you can just drag one by one. I'm going to drag and drop them here. Okay, so we're going to see that this state machine, it starts in entry and there's an arrow that's pointing to idle now, but let's not worry about this right now. Now that we are kind of telling Unity that this animator is going to deal with these 8 animations. So if you go to the animation now, it's no longer grayed out because it understands that the animator contains multiple animations inside it. So if you go to the animation here, you can see this little editor you can use, and if you click here on idle down, you can see the 8 animations that we made. All of them are empty. You can just check here in this timeline in the right that there's nothing assigned in here, but just by doing this we can already see this editor and work with it to make the animations work. Okay, so how are these animations going to work? These are going to be sprite animations. Okay, so we're going to the sprites folder, We're going to select world, and we're going to select the player here. We expand it and look here. So how is the idle animation going to work? The idle is basically going to be one single sprite of the player standing still. So to make this animation, we are going to look at the sprite where the player is looking down. We can just drag it and drop here. Okay, so if you have the player selected and you drag that here, you're going to see that you have this symbol here. It's going to work with the player game object, and it's going to change its sprite property. Okay, so this is basically the idle down animation. If you go to idle left, you can do the same thing. Grab the sprite of the player looking to the left, drop it here. It's going to understand that it's changing the sprite of the player. And we do the same thing for idle right, drag and drop, and idle up, drag and drop. Okay, that's all we need here. Okay, for idle down, left, right, and up. Now, for walking down, we have to be careful about the sprites that we're going to use. Notice that 0, 1, 2, and 3, these 4 sprites were used for setting the direction. Now we have 4 is the player, one frame of the player walking down, but 5 is walking up. So they're not exactly in sequence. So if you select things if you select sprites that are 4 units apart from each other, so player 4, player 8, player 12, and player 16, you're going to kind of see an animation working here. Okay, you actually need 4, 8, 12. Okay, look at this little square here showing the preview of the animation. If I get 4, 8, 12, 8, and I keep doing this little playing with these sprites, okay, if you use these 3 sprites, you can make an animation of the player walking. Okay, first it moves its left arm, then it stands still like this, and then right arm. So this is the walking animation that we want to use. We want to use all of these frames here. So for walking down, I'm going to drag player 4 here, player 8. I'm going to make sure it's going to be more or less here in this 10 frame mark. So player 8 here. Now I'm going to drag player 12 here, then player 8 again here. Okay, so this is one walking cycle, and to make sure that the player is not going to instantly move from this sprite for this one, I'm going to repeat the last sprite. I'm going to grab this and drop here in the timeline. Okay, so you have this guy, this one, and these 2. Okay, you can even fine-tune them by selecting these diamonds here and making sure they are in the proper frame. Okay, so 10 frames, this one's on 20, this one is on 30, and this one is on 40 frames. Okay, so this is enough for making the walking animation to work. If you want to check it working, you can even grab this scene window, put it here, and in the animation, if you press play, you're going to see the player doing the walking animation. Okay, that's pretty much what you need to make this work. Okay, let me get the scene back here. Okay, and now we have to do the same thing for the other walking animations. It takes a little bit of time, but it's a very good practice. Okay, so for the walking left, we're going to use player 6. Okay, so player 10, which is here. Make sure it's on 10. We're going to use player 14, and then player 10 again, and one more time we repeat player 10. Okay, that's the walking left. Walking right, let's use, let me see here, we're going to need player 7, player 11 here, player 15, and then player 11 twice. And try doing the last one by yourself, okay, and check on the scene to make it work. If you want, you can pause the video right now and do the player down by yourself, actually walking up. Okay, so for walking up, we're going to use player 5, then player 9, we're going to use player 13, and then player 9 twice. Okay, good. And if you want to check, you can grab the scene window, put it here, and play the animation. So walking up looks like this. Walking right, good. Walking left, like this, good. And walking down. Okay, good. And if you look on the idle ones, they should be the simplest of them because, well, there's nothing special going on here. Okay, it's just one single frame. It changes the sprite properly to the one that should work, and it's going to, well, basically work fine. And if you want to stop recording, if you want to stop editing, you can just click on this recording symbol. Okay. And before we move on to the state machines, there's also one little thing that we have to adjust. Okay, so we've edited the animations. If you go to the player folder, these files are no longer going to be empty. Okay, they have data recording in them. So what we want to do is these walking animations, all of them, they have to loop. Okay, otherwise they would just play once and then stop playing. So I'm going to select each of the walking animations, walking down, left, right, and up, and mark this loop time setting here. Okay, and when we're done with this, we need to work with the animator. Okay, so we're going to make the state machine logic for changing the animators. Okay, all of the animations. Let's work on this in the next lesson. Alright, so let's go to the animator. If you select the player here and you go to the animator, you're going to see the animator that's working here. So animators, they have an interesting way to communicate between the code files. So animators, they can have parameters. So you can just click here on parameters and we can add some things here. It's like we're working with variables. I'm going to click on this plus sign and I'm going to choose int, and this is going to be named direction x. We're going to add another int, it's an integer number, direction y. These two values here are going to be used to determine what animation is going to be working. So if you don't remember yet, if you go to the scene window and you select any game object, okay, with this transform tool selected, you're going to see that you have two arrows here. We have the red one, which is the x value, the horizontal value, and we have the green arrow, which is the vertical value, that's y. X increases to the right, okay, y increases up. So if we want the player to move to the right, we're going to use a positive value for x. We're going to use 1 on x. If we want to make it move up, we use 1 on y. But if we want to move to the left or down, we're going to use the negative values. Since x increases to the right, it decreases to the left. So if the player should move to the left, we use -1 on x, and to move down, we use -1 on y. Okay, that's why we use these two values here. And now, what should we do here? Now that we have these two things here, we need to work on this state machine here. We have multiple states, we have multiple animations, and we have to do transitions between them. So we're going to need to work with a little bit of a design here. Okay, so what we're going to do is, we're going to put idle down here in this place. Okay, and we're going to let me select this any state here and move far away from this as well. Let me put any state here. Okay, so we have idle down. We now have idle left, so I'm going to put idle left here. Idle right is going to be here. And finally, idle up, we're going to move it up to this position here, should be enough. Okay, so we have the 4 idle animations in this pattern here. But for every idle animation, we also have a walking animation. And we're going to put these animations close to the idle values. So walking down is going to be here, close to idle down. Walking left is going to be here, close to idle left. Walking right here, close to idle right in this position. And finally, walking up is going to be here on top of idle up. Okay, actually let's make it down. I'm going to move idle up here and walking up here. The order actually doesn't matter. We're just doing this in a way that is going to be easy for us to develop this. Okay, and now that we put all of these states here, okay, remember these are states, but if you look at the states, they have a setting here in motion. These are the animations. So the walking left state has the walking left animation. Idle right has the idle right animation. So if we go to these states, the correct animations are going to be played. Okay, but what we need to do now is we need to make connections between these states. Okay, so we can determine what kinds of transitions need to happen. Okay, so the first thing that we want to do is to change how the transitions are going to work for the idle animations. It doesn't matter where you stand, okay? It doesn't mean if you are on the left, on the right, top, down, but every idle animation is going to have a transition to every walking animation, okay? So we have idle down here. If we right click and make a transition, we can point to walking down. Idle down can point to walking left. Idle down can point to walking right, and idle down can point to walking up. Okay, if you select idle down, you should see here in the transitions, and you should check that you have all of the transitions set correctly. Idle down to walking down, to walking left, to walking right, and walking up. So all of the walking animations are here. Okay, we do the same thing for the other ones. Idle left goes to walking left, walking up, walking right, and walking down. Okay, so left, up, right, down. Same thing for idle up. Walking up, walking right, walking left, and finally walking down. And for idle right, walking up, actually this is idle left, let me undo this, walking left, and walking down. It could be a bit easy for you to confuse on a few things here. That's why I keep telling you to verify if all of the walking animations are here. Right, up, left, down, up, right, left, down, and walking on the 4 ones, and here 4 walkings. Okay, so good. So we have added all of the transitions between the idle states and the walking states. Also, it's very common when you are walking in a certain direction to stop. So if I'm walking to the right and I stop, the animation that should be executed is idle right. If I'm walking to the left and I stop, then it should go to idle left. So every walking state should go to its correspondent idle state. So walking down goes to idle down, walking right goes to idle right, walking up goes to idle up, and finally walking left goes to idle left. Okay, so we are nearly done. There's just one little thing missing. Whenever we are walking, we can also change directions without stopping. We are covering here the transitions whenever we should stop, but maybe we are pressing the right button, then we release it and immediately press up. We should go to the walking up animation. So what it means is every walking animation can transition to every other walking animation. Okay, so walking left can transition to walking up, to walking right, and to walking down. Walking up can go to walking left, walking right, and walking down. Walking right can go to walking left, walking up, and walking down. And walking down can go to walking left, walking right, and finally walking up. Okay, so you can review that by going to every walking state and checking. It goes to its correspondent idle state in all of the other walking states. Okay, up goes to idle up and all the other states, idle right on the other states, and walking down goes to idle down in all of the other walking states. Okay, so all of the transitions have been set here. We have lots and lots of transitions, but there's one important thing that we have to do on every transition of that. Okay, we have 8 animations, each of them they have multiple transitions, but we have to understand that each of these transitions, whenever you click on them, you can set conditions. Okay, so what I'm going to do is reduce this little panel here, and I'm going to choose each of these transitions that have been set and add a condition for them to work. Okay, so in order for idle down to go to walking down, I need to add a condition, and that condition is going to be direction Y. Okay, so we're going to move on the vertical axis. To walking down, direction Y needs to be lesser than 0. Okay, that's all we need to do. We go to this transition. To move to walking down, it means direction Y needs to be negative. To walk left, I need to add a condition and say the direction X is going to be lesser than 0. It's just like we talked before. We have the X and the Y arrows, the axis. If you want to move to the left, it's a negative value on X. If you want to move down, it's a negative value on Y. Okay, so walking down and walking left have been set. Walking right just means direction X is greater than 0. and walking up just means direction y is greater than 0. It's everything for idle down. We do the same thing for all of the other states. And again, it takes some time, but it's important to practice this. Idle left goes to walking left when direction y is lesser than 0. It goes up when direction y is greater than 0. It goes right when direction x is greater than 0. And it goes down when direction y is lesser than 0. Now for idle right, here is direction x greater than 0, walking up, direction y greater than 0. Now left, direction x lesser than 0, walking down, direction y lesser than 0. We're almost done. For idle up, walking up, we're going to add y greater than 0, to the right x greater than 0, to the left x lesser than 0, and down we're going to use y lesser than 0. Okay, and now for idle right, yes, I think we have all transitions set here, all of the conditions for the idle animations. Okay, good. Let me check idle down here as well. Okay, so apparently we have all of these set. Now we also have the walking down animations. Okay, actually all the walking animations. Let's do it reverse order. If we are walking down and we want to transition with walking up, this is simply click here. We're going to add direction y greater than 0. Okay, it's the same thing we do for changing any direction that we are working with. Walking right, x is greater than 0. Walking left, x is lesser than 0. But for idle down, why should we stop? We should stop in the idle down state if we release all of the keys. So that means direction x equals to 0, and that means the direction y, this one, it's going to be equal to 0 because the player has stopped moving. No keys are being pressed. We should use 0 here and 0 here, and this is basically going to work. We do the same thing for all of the other animations. Okay, let's go for walking right. It goes to idle right if x and y, direction x and direction y, are both equal to 0. Both conditions must satisfy for this to work. Okay, walking left, direction x lesser than 0. Walking up, direction y is greater than 0, and walking down, direction y is lesser than 0. Okay, good. Now for walking up, we're almost done. So x and y both equal to 0 equals walking left, x is lesser than 0. Walking right, x is greater than 0. And walking down, y is lesser. Walking down, yes, y is lesser than 0. And now for walking left, we're going to look at idle left here. This is, once again, x and y both equal to 0. To walk up, y greater than 0. To walk to the right, x is greater than 0. And to walk down, y is lesser than 0. Okay, so if I'm not wrong, I think all walking animations, they have their conditions set here. Okay, good. Walking down, let's check here. Yeah, so everything seems good now in this animator. We have made a huge state machine here. Actually, it's not huge, it's a bit complicated when you're dealing with 8 different directions, but the concept is really simple. Okay, if you are walking, to stop in the idle animation you have to release both keys, and in whatever state you are, to move to the correspondent left, right, up or down state, you just check for the values set in direction y and direction x. Okay, so the animator has been completely set on the player, and with this done, we should already be able to work on the script to make the player move and to make the animations to play correctly. Because right now, if we just press play, okay, if you look at the player and you look at the animator, you're going to see that we are here stopped in the idle down state. It's not transitioning because we didn't add any logic by pressing the keys to make the player move. Okay, so we're going to work on this logic in the next video. Okay, so the player is going to need a script to make it able to move. Okay, so to do this, we're going to the project folder, scripts folder, and here we're going to right click, choose create, C# script, and name this player movement. Okay, so let's name it like this, player movement. We're going to double click it to open in Mono. And also let's remember to attach this script to the player game object just to make sure we don't forget this is going to be executed. Okay, so player movement goes here inside the player game object. Good. So back to Mono. Here in the player movement, we're going to need two things. We're going to need a speed value and we're going to need an animator value. But these two things, they need to be exposed in Unity. There are two ways to do this. One of them is to simply type public float speed and public animator, and we can name this animator. Since they are public, both of these values are going to be exposed in Unity. So if you save that script and go to Unity, wait just a few seconds, they're both going to appear here and you can set both of these values as you see right now. It works, it's going to be fine, but if you want to learn some good practices right now in the beginning of this game, you have to remember one thing. When these two values are public, it means other scripts that access this player movement component are going to be able to change these. But we don't want this to happen at runtime. We don't want it to happen like this. These are values that should only be edited when we are dealing with the Unity editor. So one way to improve this is to make both of these fields private, and we can add an attribute here. We can just type between these brackets here. Let me name this serialize field. Okay, so if you hover your mouse here, you're going to see that this is a basic attribute, and it's going to force Unity to serialize a private field. Okay, so it's a private value. It can only be changed here if you want, of course, inside the player movement scope, but it can also be changed in Unity. So we did for speed, and we do it for animator. For some reason, I have a hard time writing the serialize word, but anyway. Well, that's all you need. Okay, so speed and animator are both serializable. If you save the script and you go to Unity, and once the code compiles, you're going to see that it's going to stay the same way. Okay, it's just going to be looking like this. So right now, let's already change the speed to 3, and the animator is already inside the player, so we can just drag the player and drop it here. Okay, it's going to basically reference itself and reach for the animator component. And once we're done with this, we can work on the movement logic. Okay, so this is going to be done in the fixed update method. So we're not going to use start, we're not going to use update, we're going to use void fixed update. This is different from the update because this works with the physics system. Okay, physics are simulated in a fixed time step. Okay, it's kind of independent of if you are playing on a slow or on a fast device. It's going to use the same amount of time to calculate all of the physical operations. Okay, so that's why we use this fixed update. Okay, now what we want to do is to figure out what is to check if the player should move to the left or to the right. So let's work with the horizontal movement like this. Okay, so here we're going to type float new velocity x, and we're going to start by setting this to 0f. Okay, remember, it's a floating point number, so we need this f value here. Okay, it could be just 0, but let's use 0f to make sure we understand that we're dealing with these floating point numbers. Okay, now we want to verify if we are moving to the left or if we are moving to the right. There are multiple ways for us to work on this logic, but we're going to aim for the simplest of them. I'm simply going to ask if, and between parentheses, input.getKey. This method is going to return true if you are holding down a key in your keyboard. Okay, so if input.getKey, and I'm going to pass the parameter keycode.left arrow, that means we are pressing the left arrow. So if this is happening here, the player should move to the left. The way we're going to make it move to the left is we're just going to set new velocity x to be minus speed. Okay, so remember, we have the speed value set here. Okay, and we have this internal variable that we're going to store the speed value to change it later. Okay, so if left arrow is being pressed, new velocity x is going to be minus speed. Also, when we do this, we have to update our animator to make sure our state machine is going to be connected with our script. So to do this, we type animator dot Remember, the parameters that we made, they are integer numbers. So we use set integer, and it needs a name, the name of the property that we want to use, and the value that is going to be set. Set integer, we're going to use direction x, and the value here is going to be -1 because we're moving to the left. Okay. In the same block here that we have, I'm going to add else, and we have to check if input.getKey. We check if that key is key code dot right arrow. If this is the case, the player should move to the right. So it's very similar. I'm going to type new velocity x equals to speed, so the positive value here because we should move to the right, and animator.set integer direction x, and the value is 1. Okay, now we're going to add another else block because that means the player has released both keys. If this has happened, it means new velocity x, actually we don't even need to change this new velocity x because it's already set to 0 here. You could do that just for clarity. Okay, you can type new velocity x equals to 0, just to make everything following the same pattern. And finally, animator.set integer for direction x is going to be 0. So this is the final look of this fixed update here, okay, for the horizontal part. The vertical part is very similar. So I'm going to add a comment here, vertical movement. Float a new velocity y starts at 0f. We're going to check if input.getKey, and we check for the key code. In that key code, let's check for down first. So key code.down arrow. So if this happens, new velocity y should be minus speed, and animator.set integer direction y and -1 because we're moving down. Else, if we are pressing the up arrow, so key code dot up arrow, so if we are trying to move up, velocity y is going to be positive speed, and then animator.set integer direction y is going to be the +1, so we just type 1 here. Else, if nothing else is matching here, new velocity y is going to be 0f, and animator.set integer direction y is going to be 0. Okay, so it should kind of go to the idle animation if x is 0 as well. So we did all of the logic for horizontal movement and the vertical movement, but we still have to update the velocity of our player. And to do this, we need to access the rigid body. It's one of the reasons we use the rigid body. It already implements the physics of using speed and moving things. So you can just type here game object to access the game object that contains the player component, the player movement component, which is the player itself, dot get component of the type rigid body 2D. We type this between the lesser than and greater than signs. Open and close parenthesis, as this is a method call, dot velocity, and that velocity is going to be a vector2 value because we're dealing with the two-dimensional space. New vector2. We use vector2s because we want to set values for x and for y. X is new velocity x, and y new velocity y. Okay, so that's basically what you need to make the player move. Okay, we have the speed, we have the animator, we do the logic for the horizontal movement and the logic for the vertical movement. So let's save all of this, go to Unity, let's wait for the code to compile. Okay, so let's wait just a little bit, and once this is complete, if we press the play button, let's give it a try. Let's open the console to check for errors, but the player is here, and if I try walking to the left, we play the left animation. Right animation. If we stop walking, the player plays the idle animation. Down, up. Okay, so the animations are working properly, and notice that you're also colliding with the things that have collision boxes added to them. Okay, we can walk to multiple different directions, the animations are working, the state machine is working, and the player stops moving when it should. Okay, so this is basically what we need for the player movement. Okay, you see, when you use tools like Tiled, when you can draw your own map, you can draw your own collision maps, you can easily make multiple levels, you can make this game huge, make it a very big map, and it could be easily integrated through code. Okay, it's very important for you to, whenever you're starting a project, to search for the what tools are available online for you to use and what can make your workflow much easier, because it gets as simple as that. Okay, and now that we have this, let's go to the project folder in the scripts folder. Now I'm going to right click, choose create folder. I'm going to name this player, and I'm going to move the player movement here. Okay, actually, instead of player, let's name this town. Okay, I think it's going to be better. Start battle and unit stats are going to stay outside for now, because we're going to make more scripts regarding the battles. Okay, so in the next video we're going to talk about how we can start battles and interact with enemies. There are multiple ways to trigger battles. In some RPGs, you just have to walk around in the middle of the grass, and then, well, there's going to be a random encounter. It's like an enemy is going to ambush you and try to destroy your party. But in other games, in other RPGs, you can see a specific icon of that enemy in the scene. Okay, so you clearly see who you're going to try to battle, and, well, a battle is going to be triggered. In this game, we're going to name these things enemy spawners. So the enemy spawners are going to be little indicators on the map, well, that if you collide with them, you as the player, if you touch these enemy spawners, then we're going to move on to a battle scene, and then the battle is going to begin. Okay, it's going to be basically how this is going to work. But before we even start by working with the battle, we want to make the enemy itself. Okay, just for reference, if you go back to the title scene here, also remember to save your town scene just so you don't lose anything. You're going to remember that the player party has this mage unit, which has its own sprite render, its own unit stats. Well, we're going to do the same thing for one enemy, which is going to be the snake. Okay, so what we're going to do for this is come here to the hierarchy, right click, we choose create empty. We're going to rename this game object as snake. Okay, and better than this, let's name this snake unit. Okay, name it like this. And we're going to add a sprite render to this snake. And as for the sprite, we're going to search for snake, and we're going to use this one here, snake 0. Okay, so you can even see where the snake is going to be, more or less. I'm going to put this one here. Okay, and we also are going to use a unit stats script because it's something we can battle with. Okay, so let's change a few values here. Let's use 20 for health, 10 for mana, 15 for attack, 5 for magic, 5 for defense, and finally 10 for speed. Okay, so this is going to be a basic snake unit, but the thing is, this snake is going to be transformed into a prefab because we want to dynamically instantiate this snake unit later. It's not going to be already present like this, just like we have with the mage unit. So we're going to the project folder, right click, create a new folder, and name this prefabs. And once we're done with this, we're going to enter this folder, and to transform this snake unit into a prefab, we can just drag it from here and drop it here. So it's a prefab. We can even delete it from the scene right now. It's not going to be needed here. Okay? But anyway, we already have our snake unit. But whenever we're going to spawn things, okay, whenever we want to spawn an enemy, we're not going to just spawn a snake unit, okay? We're going to spawn maybe 2 snakes, or maybe 3 snakes, or 2 snakes and 2 bats. We can have different sets of enemies. So these we're going to call enemy encounters, okay? So here, we're going to right click, choose create empty. We're going to name this game object as enemy encounter, and I'm going to drag this snake unit prefab and drop here in the enemy encounter. Okay, I'm going to duplicate this snake unit instance and put another one here, so we have 2 snakes, and I'm going to get this enemy encounter and transform it into a prefab. I'm going to drag and drop here, so we can see 2 snakes here. Let's rename this to snake encounter, by the way. But there is one important note here. Unit when you look at this snake encounter, we don't have three prefabs here. Some of you might think we have the snake encounter prefab and the snake unit prefabs, but that's not how it works in Unity. You have to be really careful about this. If you change the snake unit prefab and well, if you change its color, if you change the health points, for example, and you apply the changes for this prefab, it doesn't mean the snake encounter prefab is going to be updated. We could use another technique to make this work, but it's not going to be in the scope of this lesson. But if you change the snake unit, you have to update the snake encounter prefab as well. Okay, this is very important for you. And here in prefabs, let's make another folder. I'm going to make enemy units and put the snake unit inside here. And I'm also going to make enemy encounters. And I'm going to put this, let's rename this to snake encounter. And we're going to put it here in enemy encounters. So everything is going to be in their own folders. Okay. So now that we have this, we need to work with the enemy spawner. Okay, and now we just have the snake. Okay, and the enemy spawner, as I told you before, is something that you can touch, and once you touch it, it's going to, well, trigger a battle. So let's go back to our town scene. Here in the scenes folder, we're going to open town. Let's save changes here, even though the snake isn't there anymore. We just save to be sure. And we're going to make an enemy spawner. So in the hierarchy, we're going to right click, choose create empty. Let's move this game object to this position here, should be good. We're going to rename this game object to enemy spawner. And we're going to add a few components here. First of all, we're going to add the sprite render component, because we're going to have to add a visual here. Sorting layer is going to be game, and the sprite, well, let's click here in the circle and search for snake. But instead of using this red snake, let's use this one here, okay? Because it's going to work as an icon, just like we have for the player. It's something small. So we select the snake. Now that we have this, let's increase the scale on 2 as well to make it as large as the player, like this. Now we're going to click on add component. We're going to add a box collider 2D, okay, because that means the player can touch the snake. You can see that there's a green square surrounding the snake completely. And let's also make sure that we're going to have the is trigger selected. This is important because we're going to make a very simple collision check between the snake and the player, okay? And now that we have this, of course, we didn't implement any logic for the player to collide with this snake, okay? We just move inside the snake, okay? That's not what we want. So we need to make a script in the enemy spawner. So in the scripts folder, we're going to right click, choose create, C# script, and name this enemy spawner, okay? So now that we have this enemy spawner script, let's add it here. Okay. Actually, instead of enemy spawner, let's name this spawn enemy. Let's use this pattern for script naming. Okay, so spawn enemy. Once we do this, hit enter, wait for the code to be ready, and apply the script here. And once we do this, we have to write just a few lines for us to spawn the enemy encounter. So I'm going to get this spawn enemy script and drop it here. Good. Now we're going to double click to open this script, and we're going to add a few things. Okay, it's going to have a similar logic to what we have with the start battle script. We're going to use this don't destroy and load as well. We're going to check what scene has been loaded. So here, let's start by adding using Unity Engine scene management. Okay, we want to add a field here, so let's use serialize field and private game object enemy encounter prefab. Every enemy spawner that you collide with is going to have an enemy encounter prefab assigned to it. So we're going to spawn the enemies. In our case, it's going to spawn 2 snakes, and the player is going to be able to battle them. Also, we're going to add here a private bool spawning, and that's going to be false. This is for internal use. Okay, so in the start method, we want to make sure that this game object is not going to vanish once we switch scenes. So don't destroy and load, and we pass game object as a parameter, and we want to listen for when the scene is loaded. So scene manager dot scene loaded plus equals on scene loaded. Okay, good. Since we of course don't have this method yet, we need to make it. So private void on scene loaded scene as the first parameter, and load scene mode as the second one. And let's do something similar to what we did before. So if scene.name equals to battle, notice that this is a scene that we're still going to make. Okay, so what's going to happen is if spawning, okay, so if spawning, it is the same thing as asking if spawning equals to true, but we can leave it like this, just if spawning. We're going to instantiate the enemy encounter prefab. Okay, so if spawning has been set to true and the battle scene has just been loaded, it means this enemy encounter prefab should appear. Okay, and when this happens, we type scene manager dot scene loaded minus equals on scene loaded. Okay, let me just fix the name here and here, because this event no longer needs to be treated. It no longer needs to be, well, don't need to do anything else. And we can destroy the enemy spawner itself, because we're just going to add the enemy encounter prefab. Okay, and the most important part here, besides this of course, is we want to check if the player is colliding with the spawn enemy game object. Okay, to do this we need to write a specific name. We need to type void on trigger enter, because we're going to do a trigger collision. Okay, remember the enemy spawner uses a trigger box collider, so we need to use on trigger enter. And don't forget to use 2D. It's a two-dimensional collision. The parameter is collider 2D as well, other. And what we want to do is to check if that other thing that we collided with the player is the player. There are multiple ways to check this, but the simplest of them is to basically ask if other.gameObject.tag equals to player. The tag is a very simple way for us to give names to game objects, okay? And this is basically going to ensure that we can replace the name of the player. For example, it could be hero, it could be toy, it could be any name, but its tag can remain as player. Okay, we're going to adjust this soon. So when this happens, we're going to say spawning equals to true. And finally, scene manager dot load scene, and we pass the string battle as a parameter. Okay, so this ensures that when we are in the battle scene, the spawning is set to true, the enemy encounter prefab is going to appear, and everything is going to be done. Okay, now I can save this. Let's go back to Unity. We are going to the player here. Let's select the player game object. We want to ensure that its tag is going to be player, so make sure you have this selected. Let's save the scene. And to test this out, let's make a battle scene. Okay, so file, let's go to new scene. Let's go straight ahead and save this as battle. Remember, you have to go to file, build settings, and press add open scenes, so ensure the battle script is going to be here, and also move this battle here to the scenes folder. Okay, so if you look here, we have title, town, and battle, the three of them. So let's go back to the title here to test this entire flow. We're going to press play. The player party has been loaded. Remember, if you want to test everything along with the player party, load the title scene because it's loaded here. Let's press play. I'm going to touch the enemy spawner, and once I do this, we're going to the battle scene. But the thing is, we still haven't set the enemy encounter prefab. That's why the enemy still looks like this. Okay, we tried to instantiate it here. This is null, so the code interrupted here. That's why the spawn enemy hasn't been destroyed. So we can just go back to the town, select the enemy spawner. We have this field here. We go to prefabs, enemy encounter. Okay, let's select the spawner, and we're going to put these two snakes here. Okay, so let's just drag and drop them here. Let me just check. Yeah, we just have two snakes. Good. Okay, so when we do this, the enemy spawner has this encounter set. Let's save this. Scenes, title, let's try one more time. We press play. We are here, we can press play, we can walk around, avoid the enemy, or if we walk towards the enemy, we go to this scene. So you can see that the battle scene is starting to build up. We can already see our party activated again. Okay, we have our mage, we have our properties here, and we have these two enemies that we're going to battle. Okay, they're both unit stats, then We're going to battle them later. So from this point on, we're going to talk basically just about the battle. We are going to build the HUD here. We're going to build the visuals of this battle and start working on the logic for attacking, receiving damage, showing texts. So at some points, we're going to work a lot on doing one logic. And whenever we write a script, the code is not going to work because we need to write more scripts or more places. So we need to be patient here because we're going to build several things at once. We're going to build a big communication system to make sure that we can expand this game later and make sure it's going to be easy to add new enemies, new levels, new heroes if you want, and basically keep moving on. So let's move on to the next lesson. So this is what we have right now. We have a title scene where we can press play to start the game. We have a town scene where we can navigate, and we have the battle scene that we can enter. So the first step that we're going to take now, once we have all of this game flow here, is whenever we enter this battle scene, we need a little HUD here. We need a little interface to show some information like what player in our party is currently active, which enemies we can attack, so we need buttons for these enemies. We need a certain group of buttons that we can click to either attack or throw a magic attack or maybe just run away from the battle. So we need to implement the HUD for this battle scene. Okay, so what we want to do is go to the battle scene. Right now it is empty, but we're going to make a very simple background HUD like we had before. So we're going to create a canvas. We're going to name this background canvas, just as we did before. Render mode is screen space camera. We're going to use our main camera here. Good. And finally we go to the canvas scaler, scale the screen size, the same resolution we've been using, 1280 by 960. Good. And for this background canvas, we're going to right click, select UI image, then we're going to click here to search for the background, which is actually already here. And we're going to press set native size. Okay, so we have the same old background that we've been using throughout this entire course. But now we want to make the actual HUD here. We're going to right click, UI, Canvas, rename this as HUD Canvas. Let's move it up here in the hierarchy. Also screen space camera, main camera goes here. We change scale of screen size, 1280, 960. Okay, good. So this canvas is going to be separated into a few groups. It's important that we divide things into groups so we can make everything work in the proper way. The first thing that I want to do in the HUD canvas is to right click, choose UI, and then raw image. With this raw image, we are able to basically use a very simple color. We don't need images for that. It could be just white, red, blue, gray, right? And with this, we're going to make a certain overlay here. First of all, let's go to the HUD canvas and change the sorting layer to HUD so we're able to see our raw image. I'm going to rename this raw image to overlay. And I'm going to do a little trick so this raw image can go straight to the bottom here. Okay, we're going to click on this square where we can open some anchor presets for interface elements. And when we have this, we can change how its position works based on certain anchors in this scene. Okay, it could be the top left, could be the bottom right, it could be bottom center. And notice that if you look in this last row here at the bottom or at the right, you also have some stretch options. So you can adjust what is going to be the size of this overlay. If you hold the Alt button, you're going to also set the position for the element that you are resizing. So I'm going to hold the Alt button, or the option one, and I'm going to select this option here. We're going to stretch this overlay to the bottom. Okay, so once we click here, that white square became a rectangle and it's now bound to the bottom. So we can resize this a little bit to a size that looks good for us. We might want to review this once we are making it work, but well, it's approximately this size. And I'm going to change this color as well to a tone of gray. Okay, I think this one should be good. And we can adjust this as we go. Okay. Alright, so now that we have this background here, now that we have this working, we need to add an action menu. This action menu is going to show possible actions for the player. It could be attack, it could be throw some magic, or it could be running away from that. Okay, so what we want to start doing is to create an empty object. Okay, that object is going to store all of these actions. We do this, we worry about hierarchy right from the beginning because we're going to be able to hide all of the actions at once or show all of the actions at once. It is very important that we care about this because the interface needs to be controlled, options need to be shown, or options need to be hidden. So to start, we go to the HUD Canvas, we right click, we choose create empty, and finally we're going to rename this game object here to actions menu, like this. Make sure the position is on 0, okay, just so we don't have any surprises here. And now we want to make 3 different buttons: physical attack action, magic attack action, and run action. Let's start with the physical attack action. I'm going to right click, choose create empty, okay, just so we have a quick start here. This is going to be physical attack action. This needs an image because it's something that we need to see, and of course we need to click. So I'm going to select add a component, I'm going to search for image and add an image. As for the image, we're going to click here in the circle, and if you remember, we had an icons sprite sheet and we divided that into several other icons. Okay, so we have all of these. We're going to use this one, it's the sword, icons 13. Okay, you press set native size just to make sure the sprite is set correctly, and also we're going to press add component and add a button. Okay, so when we have this button here, it means that this button, this sword icon that we made here, can be clicked. Also, I'm going to set its position to be minus 130 on X, minus 130 on Y, and Z can be left as 0. And later we can adjust that as we want. And now that we have this physical attack action, we need to make the other two. Okay, it's going to be very simple. You can just right click here, choose duplicate. We're going to rename this to magic attack action. Its X position 0, so it's going to be centered. And let's change the icon. Let me search for a good one here. Okay, there are lots of options. So it could be this thunder icon, but I think there are better ones here. Let me just do a quick check. Let's use this book here. It's like a book of spells. Okay, we're going to use this book icon. Okay, and now we have to do the third one, which is going to be the run action. We're going to set its position on X to 130. Let's change that icon to these boots. Okay, actually just one. And one thing that we can do that is a bit better for the hierarchy here is to move all of these actions to the position Y0 again, because we can get the actions menu and move itself down. Okay, if we move the actions menu, the buttons are going to move down as well. Okay, this happens because of the hierarchy. Since all of these 3 elements belong to the actions menu, most of the changes that you do to the actions menu are going to be reflected to these buttons as well. So let's keep them here and maybe put them a little closer. Let's use minus 90 and 90 for this one. Okay, so they're going to look like this. Nice and simple, okay, very easy to see, very easy to click, so it's going to work well. These buttons, they're going to have callbacks when we click. It means whenever we click on these buttons, something might happen. Okay, if we click on the attack button, then our player is going to attack one of the enemies. Same thing for magic, and if we run, we try to leave to exit from this battle. But we're not going to implement that right now. We're just worrying about the interface. The second menu that we're going to implement is the enemy units menu. For example, when we face 2 snakes, when we have to battle 2 different snakes or bats or any enemy that we are going to use here, and we want to attack them, we need to target. One way could be to click in the icons of these enemies, but maybe there are just too many enemies and it might be difficult to click. You don't want to risk frustrating your players for misclicking into an icon. So we're going to make another menu here. Okay, I'm going to right click on HUD Canvas, choose create empty, and I'm going to rename this to enemy units menu. Okay, but how is this menu going to work? How exactly are we going to add enemy icons here? We need to make a menu item prefab. Okay, it's going to be an image that is going to work as a button, and it's going to show the icon of the enemy that we want to hit. So let's make that prefab right now. I'm going to right click, choose create empty here. It's saying game object right now, but we're going to rename this to target enemy. Okay, we're going to add an image to this. So we search for image here in add component, select image. I'm going to choose the snake for now, but don't select this one, it's this one. Okay, it's kind of a preview of the other snakes. And actually there is another one at the bottom which is better. It's snake face. Okay, we could use these ones here, but snake face looks more like a button because of this black background here. Okay, so we double click on snake face, select set native size, looks like this. We're going as well to select add component, choose button, so now there's a button for itself, and we can later change this on click effect. Okay, this is going to be adjusted as we make this game. Right now we're going to implement lots of things. It might take some time to do everything right, but once we get over this, it's going to be much better. Okay, let's also change the scale to 0.7 on X and on Y, so it's going to be smaller. And I'm going to move this to this position so we can fit more than one. Okay, probably with the scale 1 we wouldn't have enough space. Okay, so we have this target enemy here, and I'm going to transform this into a prefab. And to do that, you should already be used to this. We just select the target enemy, we drag it from the hierarchy and drop in the prefabs folder. So our target enemy button is going to be here, and then we can delete the instance from our scene. The question now is, how do we add these target enemies prefab here? The one responsible for this is going to be the enemy unit prefab. Okay, so you have to remember, we have this snake unit prefab here, and this guy is going to be responsible for adding these options. So we're going to edit the snake unit right now, but you have to remember, when you edit the snake unit, you have to update the enemy encounter prefabs just to make sure. Okay. So let's bring this snake unit here. Okay, so it's going to be easy to edit. Good. And now we're going to need two scripts. I'm going to the scripts folder. I'm going to add them now. So let's go to right click, create C# script. I'm going to name this kill enemy. And we're going to right click, create another script. This is going to be create enemy menu items. Okay, create enemy menu items. So we're going to double click on both these scripts to open them, and I'm going to tell you what they're going to do right now. Okay, so the kill enemy script is going to be something very simple. Whenever we kill the enemy, we want the menu item for that enemy to disappear. Okay, it doesn't make sense to leave something there for an enemy that's dead. Okay, if the enemy is gone, if we destroy it, it should no longer be an option, because we're not going to revive enemies or we're not going to interact with dead enemies. We just remove this button. So what we want to do here is to add a public game object menu item, and we're going to remove the start and the update methods. They're actually not needed, and we're going to add here a void on destroy. It needs to be written exactly like this, because this is automatically called by Unity when a game object is destroyed. Okay, so it means if we destroy the kill enemy script, it means that we have destroyed the snake unit. You have to understand this kind of workflow here. Snake unit is a game object. That game object is going to have the kill enemy script. So if we destroy the snake unit game object, we're going to trigger the onDestroy method in whatever script we have attached to that enemy unit, and when we are here, we're going to order this script to destroy the menu item. So I'm going to type destroy menu item. And notice that this is set to public. If we save this script right now, we go to the snake unit and we add the kill enemy. Let's just wait a little bit. If I add it here, you notice that the menu item is set to none, but we're not going to use anything here. We're not going to attach anything, the reference here, because another script is going to do that for us, okay, by reading the kill enemy script. But anyway, that's basically what we need with the kill enemy script. Now we want to go to the create enemy menu items. We're going to need a few things here, but we're going to go over them one by one. We want to add a field, so we're going to serialize it so it's exposed in Unity, and I'm going to type private game object target enemy unit prefab, like this. This is going to be that button, that prefab that we created, that is going to be added to our interface, this target enemy here, okay? So target enemy unit prefab. Let's serialize another field. Serialize field, private sprite menu item sprite. If you use snakes, this is the sprite that we're going to use. We're going to use snake face. If we use bats, then we use another sprite. It's basically the sprite that is going to be used here. Okay, remember, this can be changed. Maybe we are dealing with other enemies besides the snake. So instead of making one target enemy prefab for every enemy, you should make that a little bit more generic. So you just spawn one prefab and you edit its values. Okay? Again, serialize field, we're going to type private vector2 initial position and also item dimensions. These are going to be values that are going to help us to determine where in the interface these menu items are going to appear. And finally, serialize field, private kill enemy script. This is where we're going to assign, in this script is where we're going to assign the menu item value of the kill enemy that we are developing right now. Okay, so everything that we're going to do here is going to be in an awake method. So we're not going to use update or start, we're going to use awake. Awake happens before start, so it's important that we understand this order of execution because if we do it in the start, we cannot actually ensure the order of the script execution. We want this to happen before because this is a setup. Okay, so we go to the awake. First of all, we need to get a reference to the enemy units menu. We could do that by, well, making it a public variable here in the create menu items script and then making the assignment, but we don't know yet what enemy is going to be spawned here. So to make sure you can search in the hierarchy, in the scene for that element, you can type game object enemy units menu equals to game object dot find and then enemy units menu as a string here. Notice that this game object has a capital G. Okay, we're calling this find method, and that is a static method. It's something that belongs to the game object class itself. And what this means is it's going to search among all of the game objects in the scene for one game object that has exactly this name, enemy units menu. And we have it here, enemy units menu. So that means enemy units menu game object is going to reference this game object here, okay, which is what we want. Now we also want to see if we already have other items, okay, if we have other menu items in the game, and that needs to be done because if you have one, let's say we have two snakes, the first snake is going to be, let me illustrate that for you. Let me get the script. I'm going to put it here. Okay, so what is going to happen in this code is this. Whenever we want to add a new target enemy, it's going to check if there is another target enemy item here. If there isn't, it's going to be in this position. Okay, so let's say we are adding a second snake. It needs to check how many snakes are here, how many items are here, because depending on how many items we have, we're going to add it in this position plus an offset. Okay, because we had one snake before. If we were to add a third snake, we would do it like this. We add it in this position and then we offset twice to the right. So the third snake would be here, and so on. Okay, we need to check how many items we have here so we can do that adjustment. Okay, so let me take that off. And to do this, we're going to type game object, and since it's an array, since we can have multiple elements, I'm going to add these brackets here. Existing items is going to be, and once again we're going to call game object with the capital G because we're accessing the class, dot find game objects with tag. This is a very useful method, very useful static method when we want to search for multiple game objects in the scene and get multiple references to them. Okay, and the tag that we're going to use here is going to be target enemy unit. Okay, since we are trying to use this tag, we need to make sure that this tag is created in Unity. Okay, because if you look at the Unity application here, you're going to see that target enemy, okay, which is the item that we are using, has no tag. Okay, so we need to apply a tag here. Let's click on tag. We select add tag. We're going to click on this plus sign here, and we're going to type target enemy unit. It needs to be exactly the name that we're trying to use in this script, target enemy unit. Okay, so back to this prefab here, we still have to apply the tag, so we click here where it says untagged and move to target enemy unit. Notice that before we use the player, because the player tag is already built in Unity, but since target enemy unit is something very specific, we had to create our own tag. Okay, so I'm going to mark this. Good. Let's save our scene and save our project just to make sure everything is going to be set here. And now to calculate the position, we're going to come here. Let's add a new line, and we're going to type vector2 next position. This is where we're going to calculate where the items are going to be. So new vector2, we need to define the position in X and the position in Y. Okay, let's start by doing the simplest thing. I'm going to add some line breaks here. So we have to set a value for X and a value for Y. If we were to add only one enemy, this would be very simple. X would be initial position dot X and Y would be initial position dot Y. Simple as that. Okay, Y is not going to change in this game. However, X needs to take into account how many existing items we have here. So we're going to add an offset to this calculation. And this is actually pretty simple. We're going to add here existing items dot length, so it's going to count how many game objects we have here, and we're going to multiply that by item dimensions dot X. Okay, this is something, the item dimensions value as well as the initial position value, these two guys here are going to be defined in Unity, so we can manually set everyone's position. Okay, so this should be enough to calculate the next position. And now finally, we're going to take the prefab reference and instantiate that into the game. We're going to do that dynamically. Okay, so let's just add here a few comments. Find the units menu, then calculate the item position, and finally instantiate the item. Okay, so this is what we're going to do. Game object target enemy unit is going to be instantiate. It's a method that comes with every mono behavior. And here the first parameter is going to be the target enemy unit prefab, which we're going to set soon. And the second parameter, we're going to automatically set the parent, which is going to be the enemy units menu dot transform. When we do this, it means that this prefab that we're going to instantiate is going to automatically be under the enemy units menu in the hierarchy. If you don't do this, it's going to be in the root, so some calculations might not work correctly. It's going to be outside the menu. We're going to have several problems with this. That's why you care about doing this right now. Okay? Now we're going to type target enemy unit dot name is going to be the string target, okay, plus game object dot name. Okay, remember this create enemy menu items is going to be here in the snake unit. Okay, so when we do this operation here, we're going to say that this enemy unit is going to be called target snake unit. If we had a bat unit here, the item that we were making would be target bat unit. So we're just changing the name to make things easy to see. Now we need to change the target enemy position. Okay, so it's going to be where we calculated. To do this, target enemy unit dot transform dot local position is going to be next position. It's the position that we calculated, and it needs to be local here because we're going to, well, check the position here in Unity. So for example, let me get this target enemy and put it here. The position that we see here is local. Okay, so it's relative to the parent. So if you want to change, we're going to use some certain values here, but if you want to change it, you can just move your item to where you want, write down some values, and then put it in the snake unit. We're going to see that shortly, right? So, all right, we set the position. Now, very important here, whenever we click a button, we want a callback to happen. We want an event to happen. And that event, I'm going to declare here as a public method, it is void, and its name is select enemy target. Okay, so this is the method that we're going to make. And to make sure that when we click the target enemy unit, we're going to call this method here, we're going to type target enemy unit dot get component of type button. Okay, once we do this, you see that button is red, and it is red because we don't this script doesn't have access to the Unity interface scripts, so we need to go to the top here and type using Unity engine.ui. Okay, so you see the button is now ready to be used. So button dot on click, this is the button clicked event. Okay, this is called whenever we click the button. And now finally we're going to type dot add listener. So when we do this, we're able to call a method. So this add listener here is a method, so we need to open and close parentheses, and this is what we're going to type. We're going to open and close parentheses inside it, type an arrow like this, equal sign greater than sign, and then we're going to type select enemy target like this, like we are calling the method. Okay, so it's going to look like this. Okay, we are going to add the listener, we're going to bind it to select enemy target, and it's going to work. Also, before that, let's make sure that the scale of this target enemy unit is going to work correctly. Target enemy unit dot transform dot local scale, and that is going to be a new vector 2, and the values are going to be 0.7f, 0.7f. Okay. So finally, when we do all of these things, we also have to update the sprite of that snake. Okay, so target enemy unit dot get component of type image dot sprite. Okay, so we're going to change it. It's going to be menu item sprite. Okay, we're going to see that in action very soon. And now that we are done with instantiating the item, we have to set the menu item to the kill, actually in the kill enemy script. So we do this by typing kill enemy script dot menu item equals to target enemy unit. When we are done with this, we go to Unity. Let's wait for the code to be compiled so we can change everything else. Okay, so we're done. We go to the snake unit. Let's add the create enemy menu item script here. Okay, and we're going to add a few things. So the target enemy unit prefab is going to be this prefab that we created, target enemy. Let's drag and drop here. The menu item sprite for this snake unit is going to be the snake face. It is the one that is already in the prefab, but still it's important for you to set it here. So I'm going to click on this circle, search for snake face, which is this one. Good. The initial position is going to be minus 550 and minus 360, and the item dimensions that we use are going to be 160 on X and on Y. As for the kill enemy script, you just drag the snake unit itself here. Okay, so it's going to reference the snake unit that we have. Okay, so this is basically what we need for changing the snake unit, for adding the kill enemy, create enemy menu items. We're going to press apply here in snake unit, and we're going to remember to update the snake encounter. So I'm going to drag this prefab here. I'm going to delete these two snake units that are inside the snake encounter. It's going to break the prefab, but it's fine. I'm going to put this snake unit here, duplicate it, and add another one here. And finally, and this is very important, we select the snake encounter game object and we press apply. Okay, so this prefab has been updated, and the snake units inside it are going to have the kill enemy script and the create enemy menu items. Okay, now we can get rid of this encounter here. Okay, so after we are done with this, let's do a quick test. We're going to the scenes folder, then we're going here to title. Let me just clear the console here. We're going to press play. So we have our title, we press play. Let's go to the snake battle, and once we enter the snake battle, we have the two snake buttons here. Notice how they automatically set their positions by just having the initial position and the dimensions of these buttons. They automatically go to the proper places. If we had a third snake, then we would have a third button here. Okay, now that we're done with this initial setup of the battle scene, we need to move on and add some player information. Let's do this in the next video. Alright, let's go ahead and show some player information. We're going to open our HUD Canvas and we're going to add another empty game object inside it. So right click, create empty, make sure it's in the position 0, and here we're going to call this player unit information. Okay, let's leave it like this. This player unit information is going to have kind of 3 elements. We're going to have the player unit face, we're going to have the player's HP, that's health points, and the player's MP, mana points or magic points. Let's start by adding the player unit face. Right click, UI image. Let's rename this to player unit face. And we're going to search the source image for the mage face. Okay, let's see if we have it here. There we go, mage face. We double click here, select set native size, and we're going to move that player unit face to the bottom right. Okay, so it's going to fit nicely here in our interface. This position should be good. Okay, so we're going to add now the health bar, and that's going to be composed of 2 things. This is going to need the actual bar, so that's the image, and we're also going to need the text for that health bar, just to say HP, for example. Let's go ahead and create these things. Here in the player unit face, I'm going to right click, choose UI, then image. We're going to rename this image to player unit health bar. The source image is going to be health bar, which is already here. We're going to set its native size, so it's going to be exactly as the source file. And let's change the X position to 192 on X. Okay, actually, notice that the player unit health bar here is under the player unit face. Let's make sure it's outside it. Okay, it needs to be inside the player unit information. Okay, let's try again. 192 on X. Actually, it needs to be a little bit more, so let me put it here. Let's manually set this. Okay, and position on Y, let's use -333 here. And we also need the player unit health text. So I'm going to right click and player unit information, UI, text. I'm going to move this text down here and also make sure it's going to be big enough to show the HP information. So we're going to select this tool for resizing, change its size like this. The font is going to be Arial. Let's use 36 as font size and make sure this is high enough to fit the text. Okay, the text is going to be HP. Let's make this bold and also align to the center horizontally and down vertically. Okay, and you might want to change this color to white or to green, whatever you think is going to be better. I'm going to use white here. Okay, so we have HP. Now, there is one interesting thing about the player unit health bar. Notice that if you deal with this unit health bar and you try to scale it on X, the health bar is going to scale relative to the center. So there is a very important thing we have to talk about here. Okay, we need to talk about the anchors of this image. Okay, so if you look here in anchors, we have these positions set and on X, on minimum, maximum, and the pivot. All of them are set to a half, okay? But if you change all of these values, let me just adjust here. If you change all of these values to 0, if you change the scale of the bar, then it's going to scale like this, okay? It's exactly what we want. Every image that you make, its pivot is set to the center. Okay, so that's why, because when you try to resize things, it's going to resize equally in the left, right, top, and bottom sides. But by setting the pivot to the left, okay, when you scale, it's going to look like this. And that's what we want. Normally, games use them like this. It's a bar that decreases from the right to the left. Okay, so we need to adjust this now to ease our calculations. You could leave that on 0.5 like this, but the calculation would be much harder. And there's an interesting example in Unity of that. Notice that if I resize this bar, not only the width is changing, but the position on X is changing as well. Unity is doing that calculation automatically to us So this left side of the bar is going to stay in this position. Okay, and we would need to manually do this calculation to adjust the size of the image through code, but that would take a lot of work. Okay, of course it would eventually work. Of course, we just need to do the mathematical calculations to do this. But if you change the pivot to 0, well, you can just change the scale. Okay, notice that now that I've changed it to 0 and I'm resizing it from here, only the width property is changing. Or you can just change the scale as well. We would have the same effect. Okay, so that's what we need for the health bar. As for the mana bar, we can basically get, let me just rename this to player unit health text. We just get these two. We're going to right click and choose duplicate, so they're here down. I'm going to rename this player unit health bar to player unit mana bar, and this one is going to be player unit mana text. I'm going to select both of them by holding Command or Control and clicking on one and then on the other, and I'm going to move them down here. Okay, let's change the mana text from HP to MP, and also get the bar, change its image. So instead of health bar, we're going to use mana bar. Okay, so you have HP and MP properly set here. This should be enough for us to finish all the necessary work for setting the images. We still have a lot of work to do to make this work, but as I told you before, things need to be done step by step so we can make this work properly. Okay, we already have an interface, buttons don't work, the bars are not updated as we try to play the game, but we need to move on to other lessons so we can build this game, and in the end you're going to have this working completely. Let's move on to the next lesson. If you look at the battle scene, you're going to see all of the elements that we made so far, but there are no animations. It's a bit dull, a bit simple. Okay, there's no movement, so that's not going to bring excitement to the player when they are playing the games. So this is something that we have to care about, that we have to adjust. In order to do this, let's make animations for these elements, the snakes, the mage, and another player that we're going to make, which is the knight. Okay, let's stop the scene and let's make sure we are in the title scene, because remember, the player party starts here. We're also going to add our enemy unit here so we can change it and then update its enemy encounter. I'm going to drag and drop the snake unit here, so there we go. I'm going to now select the mage unit here, and we have to remember a few things. For the animations of the mage to work, and any unit that we make here to work, we need to have animators. So we need to make a few things. Here in the animations folder, we have the animations for the player in the town scene, but I'm now going to right click, choose create, folder, and name this mage. Inside mage, I'm going to right click, create, then animator controller. This is going to be mage controller, mage animator actually. Okay, good. To make sure this is going to be loaded into the mage unit, we can just drag this animator controller, drop it here, and the animator component is going to be automatically added. And now that we have this, we can work on the mage animations. So for every element that we make here, we're going to have 4 different animations. Let's right click, choose create, then animation. This is going to be idle, which is the default animation. Every element, every unit by default is going to be playing the idle animation. I'm going to duplicate that to make a hit animation. That's when we receive damage. We duplicate that and rename this to physical attack when we perform a physical attack, of course. We duplicate that again and we do a magical attack, okay, when we cast some spells. So we need to select the mage unit now, go to the animator and put these states here. Okay, so to begin, we're going to drag this idle animation and drop it here, so we have the idle state automatically created for us with our idle animation here. Okay, but there's one thing we have to do here. We need to add the other 3 animations. We need to add hit, we need to add magical attack, and we need to add physical attack. This is going to be much different than the player animator that we had before. And why is that? Basically, the idle animation is going to be played all the time. okay, at all times. But when we play the hit animation, the magical attack or the physical attack, they're going to animate and then move back to idle. So basically what we have to do is to make the transitions from each of these states to the idle one. So we right click on hit, make transition idle, right click on magical, make transition idle, physical, make transition to idle. Okay, and the idle animation also needs to be looping, okay, because the player is going to be moving, it's not going to just play once, different from the other animations. Now that we have this, we can actually change the animations now that we made this state machine. So we're going to mage unit here, select animation, and we can see that we have idle, hit, magical attack, and physical attack. So to help us make these animations, we're going to the sprites folder, we are going to select battle, okay, and we have our mage here. So an easy way for you to check which sprites should be used is you can just select image 0. Let me improve the size of this, and you can use the arrow keys to navigate through all of these sprites. So we have 0, 1, 2, 3, 4. Okay, when you go to 5, it's a bit different. So we can now see that the idle animation is composed of 0, 1, 2, 3, 4. Okay, so and you can see actually that 0 is the same thing as 4, so we don't even need this. It could be 0, 1, 2, 3, 0, 1, 2, 3. Okay, it's basically up to you to decide what sequence you're going to use. Okay, so let's go ahead and make that animation. I'm going to drag mage 0 and put it here, right in the beginning. Mage 1 is going to the frame 10, mage 2 to frame 20, mage 3 to 30, and we can even put 4 here because it's basically going to repeat the first one. Okay, so if we look at the scene window here, we go to the animation and press play. This is how the idle is going to work. Okay, so it looks smooth, looks good enough. That's why we use that last frame here. That's why I repeat it so it looks smooth. Okay, so the idle animation is done. Let's go ahead and make the other ones. Okay, that was idle, so let's see what animation is this. This is probably, let's use this one for the magical animation. 7, 8, 9, 10. Okay, 7, 8, 9, 10. This should be good enough for us. Okay, so I'm going to magical attack and put 7 here, 8 here, 9 in this frame, and 10. That's going to be the magical attack. As for the physical attack, let's use 11, 12, 13. Okay, so 11, 0, 12 on 10, and 13 on 20. And finally, for the hit, we're going to use 14 and 15. 14 on 0, 15 on 10. Okay, so we have all 4 animations. Let's give them a try. I'm going to play the hit animation, okay, like this. Also, notice that the frames are different, but since this last one is going to be played instantly, we should repeat mage 15 here. Okay, sometimes we have to do these adjustments, so it's very important for you to check. So it looks like this, much better. Let's see magical attack. Looks good enough. Physical attack, good enough as well. And idle, as we know, it is already working. Okay, so this is all that we do to make the animations for our mage. They're going to be played later when we are working on the code, but now we need to basically do the other animations. So let's go for the snake unit. Okay, animations, create folder. So we see we make lots of folders, we make lots of, we try to follow a good hierarchy here. So everything that you do is going to be organized and in proper places. It's just much easier to go straight to where you want by making the proper folders and, well, just diving into them and making things work. For the snake, let's create an animator controller, snake controller. Okay. So let's make the animations for it as well. Create animation. We need to use the same names, even though the snake doesn't have a magical attack. Let's create it anyway, just to make sure it's going to follow the same structure. So we have idle, we have hit, physical attack, and magical attack. Okay. The snake unit is going to have the snake controller inside it. Good. We open its animator to edit it. So there we go, we have the entry. I'm going to put idle here. And as usual, remember to set idle to loop. We're going to put hit here. Physical attack goes here. And magical attack goes there. We make transitions for each of them to the idle one. So we do the transitions here. And we can now go to the animation. Okay. Notice that we are seeing the mage unit, so that's why it's important for you to make sure to click on the thing that you're editing so we can change the idle values. And let's go to the sprites. Okay. We can collapse the mage here, we can open the snake and deal with just these sprites. So let's see how idle is going to work. 0, 1, 2, 3, 4, 5. So it's just like the mage, 0, 1, 2, 3, 4, 5. So I'm going to drag 0 here. And notice that when I'm dropping it, this time it's asking me to select between sprite render and create media items. It's asking me this because since I'm dragging and dropping in the animation here, Unity doesn't know what image we are trying to change. And there are two images in the snake unit. Okay, we have, let me check here, we have the image for it. Okay, in the sprite render we have this sprite field here. But we also have another field, which is create enemy menu items. We have this here, snake face. Since Unity doesn't know what we want to change, it's going to ask us. So if we drag and drop here, we just select sprite render. Okay, so 0, 1, 2 on 20, 3 on 30, 4 on 40. I think this one is not exactly where it should be. You could also fine-tune them by just clicking on these diamonds and making sure they are on these hard lines. Okay, so I've added 0, 1, 2, 3, 4, and 5 goes here. You can even do it like this. Okay, you can drag into the timeline. So this is the idle one. This one could be the physical attack. So that's 6, 7, 8, 9, 10. Okay, for the physical attack. So let's go 6, let's do sprite render, of course. 6, 7, 8, 9, and 10. Like this. We could even, yes, this is good enough. Okay. So we have the physical attack. We're not going to do anything for the magical attack now. You could use the ones that we have here, but since the snake is not going to do magical attacks, let's leave it empty for now. And as for hit, we can use 17 and 18. Okay, so 17 on 0, sprite render, 18 here, and we repeat 18 one more time. Okay, so to check the animations, we bring the scene down here. Okay, let's play the hit animation. Looks like this. The physical attack, like this. Very interesting. And idle, if you play it, looks like this. Okay, looping very well. So let's move the scene back here. And we should be done with the snake animations. Okay, so here in the snake unit, let's review the animator. Looks good. We're going to apply the changes to the prefab. Alright, let's go to where the snake unit was here. And let's delete, actually you can leave the prefab here because we're going to grab the enemy encounter, drop the snake encounter here. I'm going to delete these two snake units inside the snake encounter. It's going to break the prefab, that's fine. Snake unit goes here. I duplicate and I put another one here, just to update the snake encounter prefab. Okay, so let's delete this prefab as it's been saved. Okay, if you want to confirm, you can look inside the prefab for the animators of the snakes, which is good. And we can even test if the snakes are animating properly. We can just press play here, face the snake, and we can see that the snakes are playing the idle animation and the mage is also playing the idle animation. So to finish this, let's make another unit for us. We're going to duplicate this mage unit. Okay, let's move it down. And we're going to change a few of these stats later. Okay, but let's keep it the same unit stats here. But let's rename this to warrior unit. Okay, let me just check if that's in the name here. So yes, we have a warrior here. So that's going to be the warrior unit. The sprite renderer is not going to use mage 0. It's going to use warrior 0. So it is going to have this sprite here. And of course we need to change its animator as well. So you see, making new units is super easy. You just duplicate, change the sprite, and then add the animations for it, and later it's going to work just fine. In the animations folder, we create a new folder, warrior. We need a controller, so create animator controller, warrior animator. We go to the warrior unit and we put that animator here. So we have the animator controller. Now we make our 4 animations. Create, animation, we have idle, we duplicate that, we have hit, duplicate physical attack, duplicate magical attack. Okay, as usual, the 4 animations that are going to be used. Now we make sure that idle is looping, and now we need to select the warrior unit, look at the animator, and drag the idle here to make the idle state. We also drag hit here, magical attack here, and physical attack. Even though it seems like we're doing a lot of the same thing over and over again, you have no idea how important it is to practice this. It's actually very good that we are making the same step several times, because this is going to become natural for you as you make other games or as you improve this game. Okay? Make sure you add the transitions between the other states and idle, and now let's go to animation, select the warrior unit, and make its animations. So I'm going to the battle sprites folder. Let's expand the warrior here. So for the idle, 0, 1, 2, 3, 4, and that's enough. Okay, 0, 1, 2, 3, 4. 0 goes here, 1 here, 2 here, 3 goes into this place, and 4 goes into this place. And I think we should repeat 4, by the way. Okay, because 0, let me check here. 0, 1, 2, 3, 4, 0, 1. Yeah, we should repeat number 4. Okay, so 6, 7, 8, 9, 10 is going to be the attack. 6, 7, 8, 9, 10. Okay, so let's go to physical attack. 6 here, then 7, 8 in the proper place, 9 and 10 for the physical attack. So we have one for defense. Well, we're not going to use this. We're not going to use magical attacks for it as well. But well, for now we can use this guy for kind of making a magical attack for the warrior unit if you want to use it. It would be something very weak. Okay, so 12 to 15. 12 here. 13 goes into this place. 14 here and 15 here. Let's repeat 15 as well in this place. And let's go to the hit effect, which is simple. We're already used to this as well. We're going to select 16 here, 17 here, and we repeat 17 as well. Okay? To test this out, we can get the scene window, put it down here, and play the animations. Okay? So hit looks like this. Let's go to magical attack. Looks like this. Physical attack. It's a pierce with the warrior's pike, and the idle one is this. Okay, we can stop changing the animation. We can move the scene back here. Let's go back to the animator. Let's check if everything is in place. And after we are done with this, we can go back to the scene and give it a try. We now have a party with 2 elements. Both the mage and the warrior, they disappear because they're not going to be used in this scene. If we start a battle though, we can see both of them. But as you see, they're not in the proper positions here. So you can just adjust them here, looking at the player party and finding good values. So the mage, I'm going to move it to the position 0.8, and the warrior to -1. Okay, so let's memorize these values. 0.8 for the mage and -1 for the warrior. And back in this scene here, 0.8 and -1 for the warrior. Okay, so they're going to look like this in the title scene. You have to do a little bit of investigating to see what are going to be the good values for position. But once you do this, it's going to look like this. Okay, much better. We can see both of our units here, and the animations are playing correctly. Now that we have these animations, we can dive into completing the logic for this game. We need a turn-based battle system. Okay, this is going to allow the enemies to attack the players and the players to attack the enemies and try to destroy all of them. So this is going to be our focus from now on. I see you in the next video. Alright, so let's go ahead and develop a simple yet interesting turn-based battle system. What is going to happen here is that battle system is going to find all of the units that we have. It could have player units, enemy units, it doesn't matter. And it's going to keep all of these units in a list. These units, they're going to be ordered based on their speeds. Okay, so for example, if we have a fast enemy, much faster than everyone else, this is going to be the first one to attack. Once it attacks, it's going to recalculate what is going to be its next acting moment. Okay, so we're going to do a little to play a little with numbers to define who is going to attack first. Also, this system is going to enable us to attack the enemies, but we're going to do that later, okay, in a later lesson. But anyway, we need to make that turn system script. So let's move on to the scenes folder, go to battle, okay, this scene which doesn't have much information inside it, and here we're going to make a turn system game object. So we right click, choose create empty, and rename this game object as turn system. It also needs its own script, so we're going to right click here, create C# script, and then turn system. Okay, once the script finishes loading, we're going to get this turn system and drop it here. Okay, so I'm going to drag it here and drop it here, and we're going to double click the turn system script to open it. So this is going to require a few things. Okay, we're going to see things one by one, and I'm going to explain that to you. Okay, first of all, in the top of the class, we're going to type private list. List is an array of elements. It works as an array, but we have some interesting methods inside it. So that's why we're going to use this class. It's a generic array, so we have to specify what's the type of the things we're going to store. So I'm going to specify it between the lesser than and greater than signs, unit stats. And the name of this variable is going to be units stats. Okay, it's going to be an array of units. Also, we're going to need some private fields so we can add some references to us. Okay, I'm going to add here a serialized field attribute, and then private game object, actions menu, and enemies menu. Actually, enemy units menu. This is very important because the turn system is going to be responsible for activating and deactivating these two menus here. It depends on what's going to happen right now. Okay, it really depends if the enemies are attacking, if the players are attacking, if they are selecting a certain enemy. So we need to play with these two menus here. So right in the beginning in the start method, we're going to type units stats equals to a new list. Okay, this object needs to be preloaded. We need to initialize it. Otherwise, we would deal with a null element, so we wouldn't be able to move forward. And now we want to get all the player units. Okay, so add player units to the list. To do this, we're going to type game object. It's an array. Then player units, and that is going to be game object dot find game objects with tag. Remember, it's the plural version, game objects with tag, and the tag is going to be player unit. Okay, and again, this is a tag that we still don't have. We don't have player unit or enemy unit, so we should go ahead and make these two tags. Okay, let's go back to the title scene here. Let's save this scene as well. We're going to select both of our units here, and we need to apply the tags. So let's go to the tag menu here, press add tag, click on the plus sign, and we're going to add player unit. Since we are here, let's also add enemy unit. Okay, now we choose both of our player units here and apply the player unit tag. Okay, so they're both going to be here, player unit. We also need to do the same thing for the enemy. So let's drag the snake unit here. I'm going to apply the enemy unit tag and hit apply. And as for the encounter, since this is a very minor change, we can just drag the enemy encounter prefab here. I'm going to expand that, select both snake units, and choose enemy unit here. Okay, so they're both going to be set. We apply the changes to the snake encounter, and let's get rid of this. Before we move forward, let's take a look on this warning here. It says that create enemy menu items dot item dimension is never assigned. So we have initial position. Oh, so probably what we have to do here is to just put item dimensions in another line. Private vector 2 item dimensions. Let me just save this, go back to Unity. Let's wait for that to be ready. And I think it should be good. Let's just check the enemy prefab here. Okay, so dimensions are still here. Yes, so it's looking good now. Let's move back to the battle scene. Let's save the changes so the players are going to be updated. So back to the turn system. All right, now let me go here. Now we are able to fetch the player units by doing this. Since the party is going to be in the battle scene, this array is going to basically show two of our of our players. And now we want to iterate over these units. So I'm going to type for each game object player unit in player units. That means we're going to iterate over every element of this array. And every element that we're looking, we're going to give a name to it called player unit, so we can do anything code related to it. So now I'm going to type unit stats. Current unit stats is going to be player unit dot get component of type unit stats. Okay, so we're going to get this component from it. Now we're going to type a line here of something that hasn't been implemented yet, but we're still going to add it here in order for us to look at this entire script and then move on to the other script. We're going to type current unit stats dot calculate next act turn, and we pass 0 as a parameter. It's marked as red because it doesn't exist, but we're going to see that soon enough. Finally, unit stats dot add, and we pass current unit stats as a parameter, so the list here is going to be updated. Now we do the same thing for the enemies. Add enemy units to the list. So game object array enemy units is going to be game object dot find game objects with tag enemy unit. Okay, it should look like this. Now for each game object enemy unit in enemy units, we're going to do this loop here. Unit stats current unit stats equals to enemy unit dot get component of type unit stats. Good. Current unit stats, and then the same thing, calculate next act turn, and we pass 0 as a parameter, and then units stats dot add current unit stats. Now we're going to do something that is going to be used for ordering this list. Every time we change the list, we need to sort it. Okay, so sort the list based on the speeds. I'm going to type here unit stats dot sort. It's going to be like this. Okay, we're going to talk about this in a few minutes as well. Now, when we start this, we're going to type as well actions menu dot set active false and enemy units menu dot set active false. Both are going to be hidden. And then we're going to call a method called next turn, which is still not implemented, but we're going to implement it now. This next turn is going to be called whenever a new unit is going to act. It could be another enemy, it could be the player, but still this is what is going to drive the entire round mechanics here. Now here, public void next turn. So first of all, we need to get the first unit in our list. Remember, the list has been sorted, okay, because of this call here. So we want to get the first unit, which is the one that is going to act. So we're going to type unit stats current unit stats is going to be units stats in the position 0. Even though units stats is a list, we can still access elements in order like this is an array by using these brackets. And when we do this, we're going to type units stats dot remove and then current unit stats. We remove it because we're going to re-add it to our list. We're going to recalculate what is going to be its next acting turn and sort the list one more time. Okay. Now, this unit, we need to check if it's dead, okay? Because if it's dead, we don't want to do anything else. It's basically going to be removed. So we ask if not current unit stats dot is dead. Okay, this is a method that we're going to make as well, but it's basically going to check if it has positive health points. Okay, so just do it like this. This is basically asking if the unit is alive. If it is, we're going to type game object current unit is going to be current unit stats dot game object. Okay, so we're going to access that. Also, we're going to type current unit stats dot calculate next act turn. Okay, and what we're going to pass here is current unit stats dot next act turn. Okay, again, something that doesn't exist, but it's going to be implemented. We're basically getting what its current next act turn, and we're going to increment a little bit more based on the speed. When we do this, we type unit stats dot add current unit stats. So we're going to re-add it to the list. And since we re-added that unit to the list, we want to sort it again. Units stats dot sort. Okay. All of this that we are writing is not about acting, is not about the enemies attacking or you applying magic. It's just defining who is going to act first and reorganizing the list. Okay. Now that we are here, we're going to type if current unit dot tag equals to player unit. It means the player should act. But as we have no methods for the player acting, we're just going to type debug.log and then player should act. We can type also else. If it's not a player unit, then we want to print a message to the console, which is going to be debug.log and the string enemy unit should act. Okay, or just enemy should act. Now, if the player is dead, however, so we're talking about this if block, we're just going to call next turn again, else next turn. Okay, we do this because if we don't do it, then the code would stop here. We would move on to a next turn. We wouldn't move on to a next turn, and the game would basically stop. Okay, so if something is dead, it's not going to act. We just move on. Okay, so now that we have this implemented here, we need to implement the remaining methods and variables that we should add to our units stats class. Okay, so let's go to Unity, let's go to scripts, go to unit stats, and let's do some improvements here. Okay, we already have health, mana, attack, magic, defense, and speed. We're also going to add public int next act turn, which starts as 0. This is the thing that is going to be calculated on every turn. We're also going to add private bool dead. Okay, and then for the methods, we're going to type public void calculate next act turn, and it receives an int current turn here. Okay, which is the parameter. So this is basically going to recalculate the value stored here. So I'm going to type next act turn is going to be current turn, passed as a parameter, and now for the mathematical calculation, plus mathf.ceil to int. I'm going to explain that. And here we're going to put 100f divided by speed. Next act turn is an integer number, so when we do a division, we want to make sure that it's going to be an integer number with no decimal part. That's why we use this toInt type of method. It's ceiling because, for example, if the current turn is 2.2, it's going to round up to 3. If it's 4.7, it rounds up to 5. Okay, it's the fair solution here, mathematically speaking, for calculating the speed. Okay, and we do this operation here because small speeds, if we have a speed called 1, this is going to return 100. So it's going to take 100 units later of the acting turn system that we're making here. If the speed is high, however, this is going to return a small number. If the speed were 100, then this would return just 1. So that would be a very fast unit. It's important for you to understand this little mathematical system here, okay, of getting 100 and dividing by speed. Okay, we're going to also make public bool is dead, and this is basically going to return dead. okay, the value stored here. And we also need to implement something for when we sort the array. Okay, when we call unitstats.sort, we need to implement something that makes the elements of this list to be comparable. So to do this in the unit stats, we need to implement an interface. We add a comma here and type iComparable. But this iComparable interface here it belongs to another namespace. So we're going to add here using system. Okay, so we can use this iComparable. Since we have this interface, we need to implement a certain method of this interface, which is public int compare to. The parameter is going to be an object, and I'm going to call this other stats. And here we're going to type return next act turn dot compare to. Let's open and close parentheses, and we're going to compare with something else here. We need to compare this to other stats dot next act turn. However, other stats is an object. It doesn't has this next act turn. That's why we need to change this to unit stats. Okay, we're going to cast this object to be unit stats, and also we're going to put this in parentheses as well, so this call here is going to work correctly. Okay, the code is going to understand that we are calling the next act turn with this object converted to a unit stats class. Okay, so this is basically what we need for this compare to. Okay, now when we do this, we should save the script, go to Unity. Let's check for the console to see if something else was changed. Notice that dead here, it's saying it's never assigned to. It's always going to be false. Let's force it to be false just for now. This is not necessary, but since we are not changing the value of dead, let's, well, set it to false so we don't have any warnings. It's kind of weird. We are telling Unity that we know what we are doing. Okay, and now let's go to the title scene and give this a try. We go to title. Here we are, Unity RPG, play. We are going to the snake, and once we get here, we already have a problem. And that happens because the turn system doesn't have the actions menu or enemy units menu. We need to change this. So back to battle, we go to turn system. We expand the HUD canvas and put the actions menu here and the enemy units menu here. Alright, let's save that, move back to the title and press play. Okay, so there we go, play, go to the snake. We started here, and in the console we successfully printed enemy should act. Okay, so we are on the right path here. We are making that system, that turn system, and that is going to enable us to make these guys to attack the players, and later the players attack the enemies. Okay, so let's move on to the next lesson and talk about the attack logic. Alright, so let's implement the attack system. We're going to work in an unusual way to make this attack system. Attacks are going to be implemented into prefabs. We do it like this because we might want to implement different attack powers with different magic powers, with different capabilities to different elements. So for example, the player, the mage, could have its own attack properties, and the knight has its other attack properties. The mage could have higher magical powers and weaker physical powers, and the warrior would be the complete opposite of that. It would be strong, but it wouldn't have good magical powers. So it's interesting to work on these attacks like this. First of all, we need to go to the scripts folder and make a script. We right click, choose create, C# script, and we name this attack target. So we double click to open this in mono and do a few things. First of all, we need to type public game object owner. Every attack needs an owner. It's the unit that is performing the attack. And now we need to add a few things. So we're going to type serialize field, and we start by typing private string attack animation. It's the name of the animation that is going to be triggered. We also serialize field again, private bool magic attack. It's going to determine if this attack is magical or not. Same thing for the mana cost, private float mana cost. Okay, same thing for private float minimum attack multiplier. We type private float max attack multiplier, And finally, private float min defense multiplier and also max. Private float max defense multiplier. All of these fields are serializable, but the owner. Okay? Attack animation, magic attack, mana cost, minimum and maximum attack multipliers, and minimum and maximum defense multipliers. And this is basically going to have one method for now. Okay, we're going to type public void hit. Whenever we want to hit a target. So the parameter is going to be GameObject target. So we need to do a few things here. We need to get the unit stats of the owner and the target so we can do some calculations in order to perform the attack. So to do this, we're going to type unit stats owner stats is going to be owner dot get component of type unit stats. The enemy is going to be very similar. Unit stats target stats is going to be target dot get component of type unit stats. Okay, good. To perform an attack, we need to make sure that we have enough mana to do this. So we need to ask if owner stats dot mana is greater or equal to mana cost. Okay, to perform the attack. If this happens, we can already add a line in the end that is going to be owner stats dot mana minus equals mana cost. Okay, just to make sure we're going to consume the necessary power to perform this attack. All right. Now here we need to do some calculations. We start by typing float attack multiplier. Okay, and so what exactly is the attack multiplier? We do this to calculate what attack value is going to be used in a range of the minimum and maximum attack values. So we can just type here random.range and we can pass min attack multiplier and max attack multiplier as parameters. We're going to get a value between both of these. Okay, and now we type float damage. First of all, we need to check if we are doing a magical attack. So we're going to ask magic attack and a question mark. Okay, it's a ternary operator that we're going to do. First, we put a Boolean variable. It's like we're asking a question, hence the question mark. Then we're going to put the outcome if this question is true, if magic attack is set to true. If this is set to true, then we're going to use attack multiplier multiplied by owner stats dot magic. However, else, so we use this column here, if it's not a magic attack, we're going to use attack multiplier multiplied by owner stats dot attack. Okay, so just to review, we have three parts here. First of all, we ask a question. If this is true, then this is the first value that we return after the question mark. If this is false, then we return this second value here after the column. Okay, so this is what we need to calculate the damage. Now we need to move on to calculating the defense multiplier. So float defense multiplier is going to be random.range minimum defense multiplier, maximum defense multiplier, just like we did with the attack. And now we're going to recalculate the damage based on the defense that we have here. Okay, we're going to type damage, so we're going to override the damage value here. It's going to be mathf.max between 0 and another value. We do this because depending on the defense values of the target, maybe it's going to reduce so much damage it would return a negative value. So when we do this, we ensure the lowest value possible is going to be 0. Okay, so mathf.max, and here we're going to type damage minus, and between parentheses we put defense multiplier multiplied by target stats dot defense. Okay, so we're going to recalculate the damage here. Now that we have this damage value, we want to play the hit animation on the target. So we're going to type owner dot get component of type animator, okay, dot play, and actually we're going to play the animation here. In between parentheses, I'm going to put attack animation, which is the string of the animation that we want to play. Okay, now we're going to type target stats dot receive damage, and we're going to pass damage as a parameter. It's something that still needs to be implemented, but we already make this work here. Okay, so we need to implement this receive damage. To do this, let's go to unit stats here, and let's add another method, public void receive damage. And it needs to receive a float damage parameter, okay, because we need to tell how many health points are going to be lost. So now we're going to type health minus equals damage to decrease the health. And since we are being hit, we're also going to type, we also need to get the animator of this unit stats and play its hit animation. So here I'm going to add, let me put it at the top, serialize field, and then public animator. Okay, and here we're going to put animator dot play, and we're going to play the name of the state hit. Everyone has this hit state here. Okay, now that we do this, we need to also, whenever we receive a damage, we need to verify if the player is dead. So if health is lesser or equal than 0, it means that dead equals to true. Okay, the player no longer has enough health points, so it should be set to true. I'm also going to add here a game object dot tag equals to dead unit, and finally, just add a semicolon, and finally destroy game object, like this. Let's go to Unity and implement this tag. So I'm going to come here and let's select any element. Actually, we don't need to go straight to a unit. We can just go to tag, add tag, press play, press the plus button here and add dead unit and hit save. Okay, but don't worry, it's not set here to the player party. You don't have to worry about this. It's just to create the tag, just to make sure it's not going to be lost anywhere. Also, whenever we receive damage, we should put some text to work as a feedback. So we need to add 2 more values here in the unit stats. We're going to serialize field, and we're going to add a private. This one is private as well, by the way. We're going to add a private game object, and then damage text prefab. Okay, and we're also going to add here a private vector2 damage text position. Okay, we're going to add a text to the game, change its text, of course, and set its position. Since we're going to deal with texts, we're going to add a namespace here using Unity Engine.ui. Okay, so what are we going to do here to implement this text? First of all, we need a reference to the HUD Canvas, because this is where the text needs to be. Game object HUD Canvas is going to be game object.find HUD Canvas. Okay, remember, it needs to be exactly this name. Now, game object damage text is going to be instantiate to dynamically add it to the game, and we pass damage text prefab. Okay, and also HUD Canvas dot transform. So it's going to be its parent. Okay. Now to change the text, we're going to type damage text dot get component of type text dot text to change its string is going to be, I'm going to add 2 double quotes plus mathf dot let me use this as floor to int, and I'm going to put damage as a parameter. Okay, so it's basically going to change whatever text we have there to the number of the damage that we are using here. Now, damage text dot transform dot local position is going to be damage text position, like this, and damage text dot transform dot local scale is going to be vector2.1. This line here is for basically setting the text to be in the position we are determining, and this one is to make sure that the scale is going to be 1. It's important to do this because when you instantiate elements and set its parent, the scale might change depending on the scale of the elements that we have here. Okay, it's important to do this to ensure that it's going to work properly. Okay, so now that we have this, the attack target should work fine. We now have this receive damage is no longer red, but there are a few things we have to set. First of all, let's make this damage text prefab. Okay, I'm going back here. Let's go to the battle scene. Let's do it there. Scenes, battle. So in the HUD canvas, I'm going to right click, create UI, and then text. I'm going to name this damage text. Okay, let's use this tool here, increase its size. I'm going to change this text to 9,999 just to make sure it's going to be big enough for many cases. Font size 36, then it's going to be bold, and I'm going to change the color to red. Okay, it should be bigger, by the way. Let's use 50. Yes. Let's align in the center horizontally and center vertically. And now that we have this, it should be enough for us to save the damage text into a prefab. I'm just going to drag and drop here in the prefabs folder. Okay, damage text. I'm going to delete it from here, and now we have to update the units to put the necessary values there. I'm going to save this scene, go back to title, and go to our units. Remember, we have new things on every unit, so we have to update them. We have the animator, the damage text prefab, and the position. So, for the animator of the mage unit, we just reference itself. We drag and drop it here. Not on the text prefab, it's going to be here, animator. Damage text prefab, we just grab this damage text and drop it here. And for the text position, let's use 0, 0. So we do the same thing for the warrior unit. Drag and drop here. Damage text prefab goes here. Text position 0, 0. I don't think there's anything else besides these two settings. So let's also update our enemies. Snake unit. The animator references itself. Damage text goes here to the prefab. We hit apply. Let's leave the snake here because we're going to update the enemy encounter. So we have the snake encounter. I'm going to take its two children off here. Snake unit goes inside the snake encounter. We duplicate it, move it to another position, maybe here or here. Select the snake encounter, press apply, and everything is going to be updated. Now that we have dived into implementing this receive damage, we need to go back just a little bit more to create the attack prefabs. Remember, we have this new attack target script here, okay, with the hit, with multipliers, but we need to make some prefabs. So let's go to the battle scene here. I'm going to right click, hit create empty, and I'm going to rename this game object to magical attack. Okay, we're going to add our attack target script, and we're going to set a few things. First of all, owner is going to be left like this. The attack animation is magical attack. Okay, since this is a magic attack, we're going to mark this checkbox, and we're going to set a few values here. Mana cost 10, minimum attack 0.4, maximum attack 1.2, minimum defense 0.2, maximum defense 0.8. This is the magical attack. I'm now going to duplicate it, rename this as physical attack. Okay, we have two game objects now, magical attack and physical attack. And as for the physical attack, the attack animation is physical attack. It's not a magic attack since it's physical. Mana cost 0, as we're just using our fists, for example. 0.3, 1, 0.2, 0.8. Okay, so we have the magical attack and physical attack game objects here. Let's go to the prefabs folder. We're going to create a folder here, name this attacks, and we're going to put both magical and physical attack inside here. Let me just open the folder. Both of them, actually need to drag one by one. So magical attack, physical attack. Let's also put damage text and attacks here. I'm going to make a new folder named UI, and I'm going to put the target enemy here as well, so it's organized. Okay, so we have magical attack and physical attacks both in the attacks prefab folder. We can already delete them. Okay, we already implemented the attacks. So with this, we are nearly finishing our attack system. Okay, attacks, they have information, they have numbers, they have values set on them, and now we have to use these values. Okay, so what we have to do is create two scripts. We need to create the enemy unit action, and then we need to create the player unit action, so we're able to use these attacks. Let's talk about this in the next video. So for the attack systems, let's make the scripts that we're going to use. First of all, I'm going to make a folder here, create folder, and then I'm going to name this attack. I'm going to put attack target here, and inside this folder we're going to create two scripts. Okay, so right click, create C# script, and let me delete this one, it wasn't good. Create C# script. This is going to be enemy unit action, and after that we're also going to create player unit action. Okay, first one is here. Create another script, player unit action. We hit enter and both should be good. Alright, so let's go for the enemy unit action. First of all, we're going to add a serialized field here, attribute, and type private game object attack. Okay, so what's going to happen here is this attack is actually an attack prefab. It's something that the enemy is going to instantiate and use it to attack somebody. Okay, we're also going to add here a serialized field and put private string targets tag. Since we're talking about enemies, the targets tag is basically going to be the player unit. Okay, so now we're going to use the awake method. So I'm going to type void awake. We use the awake because this is kind of a preloading instruction, and what we're going to do here is we're going to type, let's make another field here. Let's make a private. No, actually this is not needed, never mind. So in the awake method, this is what we're going to type. Attack is going to be instantiate attack prefab. Okay, I'm going to type here private game object attack. This is going to be better. Okay, just so we don't use the same variable for two things. This is going to hold the instance of the attack, and this is going to hold the prefab. Okay, so attack is going to hold the instance of attack prefab. Also, we're going to type attack dot get component of type attack target dot owner is going to be game object. So it means the owner of this attack is going to be the enemy unit action. Now, how are enemies going to work? They're basically going to get a random target along all of the targets that we have and attack that target. To do this, we need to make a method. So I'm going to type private game object find random target. And this is how it's going to work. Just like we did with the turn-based system, we get a list of all the possible targets. So that's going to be, we need to find some units. I'm going to type game object, open and close brackets, and then possible targets is going to be game object dot find game objects with tag, with the tag that we determine here, targets tag. Okay, so we have this list. Now, what we want to do is to check if we have multiple targets here. If possible targets.length is greater than 0, we're going to do something. Else, what we're going to do is return null. Okay, if there are no targets available, we are going to return null. But if there are targets available, we need to get a random target over the possible solutions. So to do this, we're going to type return possible targets, and between brackets we need to get an index. It could be 0, 1, 2, 3, it depends on the size of your party. To make this independent of the size of your party, you can just type here random.range. First parameter is 0 and the second one is possible targets dot length. It's going to return a number between 0 and this minus 1. So if we have 3 targets, the possible outcome for this would be 0, 1, and 2. If we had 5 targets, the possible outcomes for this call would be 0, 1, 2, 3, 4, which are valid numbers when you are using them to as indexes of an array. Okay? Arrays are 0 based in C#. So if you have 3 elements, it starts at 0 anyway, 0, 1, and 2. Okay? So this is what we have here. Now I'm going to add a public void act. This is one of the most important methods here. So we're going to type game object target is going to be find random target. Okay, and after this we're going to type attack dot get component of type attack target dot hit, and then we pass target as a parameter. So now finally the attack target is finally going to hit something. Okay, it's going to hit a random player that we have in our party. Okay, so this is the enemy unit action. Now we need to do something similar to the player unit action. Okay, so this is what we're going to do here. Serialize field and then private game object physical attack prefab. We serialize to it again, private game object magical attack prefab, and we also have private game object current attack. Okay, so this is what we're going to do. We're now going to implement the awake method, void awake, like this, and we need to have here a private game object physical attack and private game object magical attack. So physical attack is going to be instantiate physical attack prefab, okay, and it's going to be under transform. It's going to be a child of player unit action. So a very similar thing to the magical attack. Magical attack is going to be instantiate magical attack prefab and transform. So we set the parent. Now physical attack dot get component of type attack target dot owner is going to be game object, so it's going to be the game object of the player. And same thing for magical attack. We can even copy this line, paste it here, and type magical attack. Okay, and for now we're going to type current attack equals to physical attack. Okay, so we set it as physical in the beginning. We're now going to implement the act method, so public void act game object target. We're going to act on a target, but different from the enemy, we need to specify that target, which we're going to do in another lesson. And here we type current attack dot get component of type attack target dot hit, and we pass the target as a parameter. Okay, so these are the unit methods that we are making. We made player unit action and the enemy unit action. Now that we have both of them, let's add them as components of the scripts of the units that we have. So in scenes, we move back to the title. Let's save the scene just in case. And for both mage unit and warrior unit, we're going to click add component and then add player unit action. Okay, and we're going to set their prefabs. So we go to the prefabs folder, attacks. So magical attack goes here and physical attack goes here. Okay, you do this for both units to make sure the prefabs are properly set here. Okay, now let's get our snake again. Let's update it. We're going to add component enemy unit action. For the prefabs, we're going to use the same attack prefab as we have here, the physical attack, and we need to set the target tag. Remember, mage unit and warrior unit are both player unit. They have this tag set here. So if you go to snake unit, this has to be player unit. Okay, it has to be the exact same name that you have. Right now we're going to press the apply button to save the unit, and one more time let's update our enemy encounter. Snake encounter, snake unit, and here let's delete these snakes, break the instance, snake unit goes inside snake encounter, we duplicate it, we put it here, and we press apply to save our snake encounter. Okay, so let's delete this, let's save, and then now that we have done all of these things, we can move on to where we've defined the next turn in the turn system. Here we've put these console messages just because we didn't have any act scripts, but now we can update this. At the enemy round, which is this one, we can type current unit dot get component of type enemy unit action dot act. So it should hit one of our players. Okay, let's save this. Let's wait for the code to compile, go to Unity, and give this a try. So we press the play button, we play in the title, collide with this snake, and so as you see, the snake attacked, we had the text showing the amount of damage that was done. And if you pay close attention to your party, you're going to see that the damage animation was executed as well. Okay, let's see that with a bit more care. So I'm going to zoom in here, press play, and pay attention to this area. Okay, so the warrior was hit. Notice that the text, however, stays forever here, which is something that we don't want. So what we have to do is we go to the unit stats here, or reset the damage text, and you're going to type destroy, then damage text here dot game object like this, and then we can specify the time it's going to be alive. I'm going to put 1f, so 1 second for the text to disappear. You can try that again. You just go back here, wait for the time to pass, and you're going to press play. There we go. Once we do this, we can play collide snake again, and the text is going to appear, and after 1 second disappears. Okay, so now the enemies are attacking, but now we need to be able to attack them back. Of course, we need to react and, well, select our players, attack our targets, and move on to finishing this game. Let's do this in the next lesson. Alright, let's continue. Now we need to be able to select attacks. Okay, we could start playing with the magician, then throw some magic powers into the snakes, then we could play with this warrior and attack. So we need to be able to select units and play with them. So we need to do a little bit of an improvement in our player party in the title scene. What we're going to need is to make a new script. So we right click, choose create, C# script, and we're going to name this select unit. Let's hit enter. Let's wait for the code to compile and continue. We're going to select our player party, attach this script here. Okay, so we have start battle, we also have select unit, and continue working here. Just like with start battle, we need to check what scene we're currently in. So we're going to use the scene management using Unity Engine.scene management. What's going to happen is this select unity script is going to need to be able to identify the actions menu and the enemy units menu, but these things only exist in the battle scene. So we're going to make a little check here. Okay, so let's declare a few variables. Private game object current unit. As the name says, it's going to determine which player unit is currently active. We also are going to type private game object actions menu and private game object enemy units menu. Okay, we're going to use these three variables here. First of all, let's remove this for now. We're going to use void awake to identify if a scene has been loaded. Scene manager dot scene loaded plus equals on scene loaded. We're going to implement that method, so private void on scene loaded. We need the first parameter as scene, the second one load scene mode. Okay, so here we need to check if the scene is the battle one, because if it is, we can define who is the action menu and who is the enemy units menu. So if scene.name equals to the string battle like this, then actions menu is going to be game object.find with the string actions menu, and enemy units menu is going to be game object.find enemy units menu. These need to be exactly the same names as the ones we have in the battle scene, but if you follow this tutorial with the same names, it should work just fine. Now we're going to implement public void select current unit, and this is going to receive a game object unit. Okay, so when we call this, we're going to set what is the current unit. So we need to set current unit to be unit, which was passed as a parameter here. And when we select a unit, and this is very important, we need to activate the actions menu so we can determine if we're going to attack, to apply a magical attack, or to run. So actions menu dot set active true. Now we also need a public void select. Okay, we already select the unit. We should be able to also select an attack. Okay, so here I'm going to put bool physical. We're going to determine if it's going to be a physical attack or a magical one. Okay, so when this happens, we're going to type current unit dot get component of type player unit action. Okay, we're going to get this component and then select attack, and we're going to pass physical as a parameter. As usual, this is a method that still needs to be implemented, but we're going to get there. It's just to determine the current attack. If you remember, if you go back to player unit action, we are defaulting it to be physical. But what we need to do here is type public void select attack, then bool physical, And when we do this, we need to type current attack equals to, is it physical? If it is, then we return physical attack. If it isn't, then we return magical attack. Okay, we use this ternary operator to set the current attack very simply like this. Okay, so select attack is done. Back here, select attack has returned to normal. Okay, so this is good. Then when we select the attack, we need to type actions menu dot set active, and we determine this as false because we already selected the attack. And then enemy units menu dot set active, true, because we need to select the enemy we want to hit. And finally, and this is the last step when we are selecting who the unit is going to attack, what attack is going to be used, we're going to type public void attack enemy target and then game object target. Notice that reading these three elements is like telling a story. We first select which player is going to attack, then the player is going to determine their attack, if it's physical or magical, and then they're effectively going to attack. Okay, it's a three-step process to make the player interact with the game. Okay, now here we type actions menu dot set active false, enemy units menu dot set active false as well, and finally current unit dot get component of type player unit action dot act over the target that the player selected. Okay, this is basically what we need for this select unit script. Okay, and now that we have this complete, we can move on to let me check here, let me open Unity, let's go to scripts, we're going to open the turn system here. Okay, let's wait a little bit for it to be done. We open the turn system, good. And here, instead of making this check here, this verification, we're going to type player party, which we need a reference to as well, dot get component of type select unit, like this, dot select current unit. And that select current unit is going to be current unit dot game object. So we're properly selecting the current unit in the player party, but we also need a reference to this player party. We could do here game object dot find player party. It could work like this. Okay, game object dot find player party, we call the select current unit and we pass the current unit here. Remember, this current unit is what we get from the list of units stats. Since we are here, it means that unit is a player unit. That's why this is going to work correctly. Okay? Now, to select the attacks, however, we need to find a way to make a communication between the buttons that we have in the battle scene, which are these three, and the players that we have. The problem is they don't have their on-click methods yet defined, but and they also need to be defined dynamically because we still don't have a player party here. Okay, so we're going to make a new script here. So let's go to scripts. I'm going to right click, choose create, C# script, and this is going to be add button callback. Okay, we're going to double click to open the script and add just one serializable field, which is going to be physical, private bool physical. Okay, in the start method, we're going to type game object dot get component of type button. Okay, not add button callback, just button. You should add the namespace here as well using Unity engine.ui. Okay, there we go. We're going to get the button, we're going to type on click and then dot add listener, just like we did with the enemy unit in the interface. Here in add listener, we open and close parenthesis, equal sign, greater than, and then we call the method add callback, which we're going to define right now. Okay, this is just us using this method to be called whenever we click the button. Okay, and here, instead of the void, we're going to type private void add callback like this. Good. And here we're going to type game object player party equals to game object dot find a game object with the name player party. Okay, and then we type player party dot get component of type select unit dot select attack, and finally this is going to complete the link between clicking in the button and actually selecting the attack. Now we pass physical, which is determined here. Okay, and now that we do this, we need to update the physical attack action and the magic attack action. So let's go to Unity. Let's wait for this to compile, and once this is done, we're going to select the HUD Canvas here. Then we're going to select the Actions menu, and for the physical attack action, we're going to click Add Component. We're going to add the Add Button Callback script and mark Physical for this one. And in Magic Attack action, we're going to click Add Component, Add Button Callback, and we don't need to add Physical. Okay, this is what we need to be able to click these two buttons and perform the attack. Now we need to move back a few steps to the enemy buttons that we created that were here. Okay, so just to remind you, here in the prefabs folder in UI we have this target enemy script. Okay, to create this here, we've added another script before, which is this create enemy menu items, and here we made a method called select enemy target, which is set as doing nothing right now, okay, because we still couldn't perform the entire attack logic. But now that we can, now that we've implemented the methods of this lesson, here in the create enemy menu item script, we can type game object party data equals to game object.find player party, and then party data dot get component of type select unit dot attack enemy target, and when we reach this we type game object. So we're going to attack this enemy here. Okay, so this should be enough for being able to attack the enemy. Now that we have this logic working, we should implement the changes to update the HUD. Okay, so we can update the health points, we can update the player's face. So let's do this in the next lesson. To update the HUD elements that we have here, we're going to implement an interesting abstract system. So in the scripts folder, I'm going to create a new folder called UI, and inside the UI folder we're going to right click, choose create, C# script, and name this show unit stat. Okay, I'm going to open this, and this show unit stat here is going to be in public abstract class, because this is not going to be used directly. We're going to extend this class for when we want to show the unit's health and the unit's mana. So this is what we're going to need to do. Okay, so first of all, we're going to serialize a feud here, and this is going to be a private, actually protected in this case, game object unit. Okay, so we serialize feud again, and private float max value. And we also use private vector2 initial scale. Okay, we use this to know the initial scale, and then we can change the scale of the bars that we are using. In the start method, initial scale is going to be GameObject.transform.local scale. We're going to save this information in this method. In the update method, we're going to type if unit is different than null. If we have a unit kind of related to this show unit stat script, okay, so if we are showing player 1 or player 2, it doesn't matter, we're going to call float new value is going to be new stat value, which is a method, an abstract method that we're going to define soon. Float new scale, and then we're going to do a very simple calculation here. Between parentheses, we're going to type initial scale dot x multiplied by new value divided by max value. Okay, so this is for the new scale. And finally, to actually change the scale, we're going to type GameObject.transform.local scale is going to be a new vector2, and finally we're going to put here new scale on x and initial scale dot y on y. Okay, so we just changed the scale of the bar horizontally, just like I told you before. We don't change anything vertically. Alright, and the interesting thing here is that this new scale is going to return kind of a value between 0 and 1, between 100%, which is the full bar, and 0%, which is an empty bar. Okay, so let's move on. We're going to need other things here. We're now going to type public void change unit and type game object new unit here. Once we do this, we're going to type unit equals to new unit. This method is very important because this is what is going to determine which player's data is going to be shown, if it's the warrior's data or if it's the mage's data. And finally, we type abstract protected float new stat value. Okay, this is going to be calculated and this is going to be implemented in the specific show unit stat scripts, and I'm going to show that to you now. Okay, we're going to Unity. Let's wait for the code to be ready, and we're going to make two scripts here. Okay, the first one I'm going to create C# script is going to be show unit health. So this show unit health is going to extend show unit stat, but this script is going to be much shorter because we're just going to access the unit's health. We do the same thing for the mana. So show unit mana. We open both scripts, health and mana. Both of them are going to extend show unit stats. Okay, actually show unit stat, just one in singular, like this. This one, show unit stat. Okay, both of them are extending show unit stat, and all that we have to do here in the health part is going to be override new stat value. If you type override space and then hit enter, we already have what we need to type for the new stat value implementation. Protected override float new stat value. And here we're going to type return unit dot get component of type unit stats dot health to access the health. I'm going to copy this method implementation here, save the script, go to mana, and I'm going to paste it here. But instead of returning the health, we're going to return the mana. Okay, so this is what we need to make these two things work. Now that we have these set, we need to go to the health and the mana bars, which should be here in player unit information, and add the script, of course. In the health bar, we're going to add show unit health. There we go. Max value, let's set this to 100. Let's define that as the maximum one. For the mana bar, again, show unit mana, but this time maximum value is going to be 100 units. Now when this happens, we need to set the units properly. Okay, so we need to go back to the select unit script here. Okay, and we have the select current unit script, right? And when this happens, we're going to type current unit dot get component of type player unit action. Okay, and we're going to call a method that we're going to implement right now, which is update HUD. Okay, it's going to be red because it doesn't exist yet, but we're going to our player unit action script to implement this, okay, which is here. All right, so here we're going to do two things. We're going to add a new field, so we serialize a new field. Okay, we're going to make a new one. Then we're going to type sprite face sprite in the player unit action script, which is going to be updated soon. And finally here we're going to implement public void update HUD. So inside this we're going to make three things: update the bars and then update the player's unit face. So here in update HUD, game object player unit face is going to be game object.find player unit face, which is present in the battle scene with this exact name. And then player unit face dot get component of type image. Okay, actually just image here. Since we're going to deal with UI, we need to use Unity engine.ui here at the top of the script. Okay, here dot sprite, and this is going to be face sprite, which is going to be determined on every player unit. To update the health bar, game object player unit health bar is going to be game object.find player unit health bar, should be this exact name here, and then player unit health bar dot get component of type show unit health, this one, dot change unit, and we pass game object as a parameter. And for the mana one is going to be almost the same thing. Game object player unit mana bar is going to be game object.find player unit mana bar. Okay, and now player unit mana bar dot get component of type show unit mana dot change unit game object. Okay, so it's going to show the correct data. All right, now once we have this, we're going back to Unity and we need to go to our title scene to update our player units. Okay, wait a little bit, we go to scenes, then title, and in the player party, notice that we have, let's see here, in the player unit action, we have the face sprite. So for the mage unit, the face sprite is going to be made, let me see here, mage underline face. So we set it here. And the warrior unit face sprite is going to be warrior underline face, which is this one. So let's save this scene to make sure everything is going to be executing properly. And after this, we need to implement the logic for finishing the battle, okay? Because when we are able to finish the battle, after this, we should finish the adjustments for making the entire turn logic work, okay? It's not going to work entirely right now, but we're getting there, okay? So let's work on finishing the battle. Alright, so there are 3 conditions to finish the battle. These conditions are: if all enemy units are dead, the player won. If all player units are dead, then the player lost, or the player might run from the battle. We need to start with when the player wins the battle. When this happens, we need to collect the reward. So we need to make a script for this. I'm going to right click in the scripts folder, create C# script, and name this collect reward. We're going to open this collect reward script and add a few things. First of all, we add serialize field to add a private float experience. Okay, whenever you destroy an enemy encounter, you're going to receive a certain amount of experience points. Okay, in the start method, this is what we're going to do. We're going to type game object turn system is going to be game object dot find a game object with the name turn system, written exactly like this. Now, turn system dot get component of type turn system dot enemy encounter, which we're going to set, is going to be game object, like this. Now we go to the turn system and we're going to add here a public game object enemy encounter. Let's save it like this, okay? So back to collect reward, everything looks back to normal. Here, we're going to add a collect reward method. We're not going to use the update method, okay? So let's type public void collect reward, like this. Now, game object array living player units is going to be game object dot find objects with tag, and we're going to pass the tag here player unit. We want to know how many remaining players are going to be here, because this is going to depend well on how many if you have many players alive, you're going to have more experience. If you have less players, then that's going to be less experience. So we're going to type here float experience per unit is going to be experience divided by living player units dot length. Okay, so this is what's going to be the calculation for that experience per unit. Let me just check here why this is marked as red. Yes, actually the collect reward script has the same name here, so let me name this get reward. Should be enough. Let's name this method get reward. Okay, so now that we calculated the experience per unit, that means that we're going to distribute the total experience of this enemy encounter between every enemy, so between every player. So if an encounter is going to give you 100 experience points and you have 2 living units, each unit is going to receive 50 experience points. Okay, so for each game object player unit in living player units, we're going to type player unit dot get component of type unit stats dot receive experience, and we're going to pass experience per unit as a parameter, like this. Okay, and after we call this get reward, we should also destroy the game object itself. Since we are trying to use this method here, we need to go to unit stats here. So we go to the declaration. This unit stats is going to have an amount of experience points. So I'm going to add here a public float current experience, or just experience here. And in the end of the unit stats script, I'm going to type public void receive experience, and then here float new experience. And now we can type experience plus equals new experience. And this you can use later to implement some sort of level system for each of these units. Okay, it's good to have this ready. Now, to finish the implementation of realizing if the player won or lost the game, we need to do some changes. We need to open our turn system here. Okay, so whenever we call next turn in this place here, before we move forward, we have to check a few things. Okay, we want to know how many enemy units are left. So I'm going to type game object array remaining enemy units is going to be game object dot find game objects with tag, and here we're going to type enemy unit. Remember, whenever an enemy or a player is dead, their tag is replaced with dead unit, so this is not going to be found here. So we're going to ask if remaining enemy units dot length equals to 0, it means we have successfully killed all enemies. So we need to collect the reward. So enemy encounter dot get component of type collect reward dot, and then here we're going to type collect reward, which we renamed to get reward actually. Okay, and now if we beat a level, we're going to move back to the town. So scene manager dot load scene, and we pass town as a parameter. Since we are trying to switch scenes, we also need here to using Unity engine dot scene management. Okay, so this is the verification to check if we beat all enemies. We also need to check if we were completely destroyed. So check if game over. Game object array remaining, and then let's say this player units is going to be game object dot find game objects with tag, and then this is going to be player unit to get all the live players. Now if remaining player units dot length equals to 0, that means we have lost the game, so we're going back to the title scene. Scene manager dot load scene to the title scene like this. And now the other way to exit from a battle, to well, basically run from it, we need to implement another script. So in Unity, we are going to wait for the code to compile here, just to make sure everything is going to be updated. And now we're going to right click, choose create, C# script, and name this run from battle. Okay, I'm going to double click this, and here we're going to add a field, serialize field, and then private float running chance. Okay, so there's going to be a certain chance that you can run from the battle. If you don't run, then you're basically going to lose your turn and get hit again. So you have to really think if you really want to try to run from a battle. Let's set this as 0.5 by default. Okay, so here we're just going to add one method, which is going to be public void try running. And this is how it's going to look like. We're going to type float random number is going to be random dot value. This is going to return a random value between 0 and 1. It's like getting a value between 0 and 100%. And what we want to know is if that random number is lesser than running chance, if it's smaller than running chance, then it means we successfully ran away. So scene manager dot load scene town. So we go back to town. We also include the Unity engine dot scene management namespace here. Okay? Else, that means we just lost a round. We weren't lucky enough to get away from this battle. So we need to get our turn system by typing gameObject.find turn system dot get component of type turn system, and then we call the next turn. Okay, so basically we just lost our chance to fight. Okay, so now we're going to save this, go to Unity, we wait for it to compile, and now we're going to put everything together to make this game work. So we're going to do this in the next video. Alright, so now that all these changes have been implemented, we could try to play the game. If we press play here in Unity, then press play, try to beat the snake, we are attacked, but we still can't act here. The problem is we need to call next turn after something happens. And we should do this whenever we receive damage, because it means the player's or the enemy's turn has finished. But when this happens, we also have to wait for a few seconds before moving to the next turn. So what we can do here at the bottom of the receive damage method is type game object dot find turn system dot get component of type turn system again dot wait then next turn. Okay, this is a method that doesn't exist, so in the turn system here at the bottom I'm going to add public void wait then next turn. Here we need to call a coroutine so we are able to wait for time to pass before doing something else. So I'm going to type here start coroutine wait then next turn routine. And finally, our last method is going to be private IEnumerator wait then next turn routine. And here we type yield return new wait for seconds to wait for 1 second. Okay, so we pass 1.0f as a parameter, and then we call next turn like this. Okay, so we're going to save this. Let's go to Unity, wait for the compilation to be done, and after that's complete we are able to press the play button here. We can press play and we are attacked. After 1.5 second passes, 1 second passes, we select the warrior. Now we can choose an attack. I'm going to choose this one and attack this snake. I killed it. This snake attacked. Now I'm going to play with the mage, magical attack, select the snake, and we're able to try to destroy it. Okay, so we get it, and there are two little things we still have to do. Okay, first of all, we're still not able to run because we didn't implement this in the last lesson. So let's go back to the battle here. I'm basically going to select the run action, add component. I'm going to add the run from battle script here, and in the run action we're going to add a button callback to itself. So we just, in the on-click panel, we click on the plus sign to add a new one. We drag the run action itself here, and the callback is going to be run from battle, and then we're going to call the method, which should be here, try running. Okay, so this should be enough to, well, run away from the battle. So let's implement that first before moving on to the collect reward logic. So we're going to play here, press play, come here, go to the snake. We are attacked. If we try to run, notice that I wasn't lucky enough. I'm going to try again, and this time I was lucky enough. Okay, and notice that we are still being hit. The health points are being decreased. Okay, you can see them being updated. The warrior has been hit a few times, so we can see health points getting diminishing over time. Okay, so that part is done. But the only thing that's left now is whenever we try to collect the reward, a bug is happening here. So let's kill these snakes. We got one. Let's get the second one. There we go. And if you see the console, it says here the variable enemy encounter of turn system has not been assigned. If you double click here, MonoDevelop should show you exactly what the problem is, but if it doesn't, you can just check here, turn system line 48. So in turn system line 48 here, it's trying to use enemy encounter, but it's not working correctly. Okay, so we need to find out why this is happening. Let's take a look on this. So what we need to do here is to look at our prefab. Let's go to project, we're going to prefabs, enemy encounter. The only thing that's missing is, of course, add the collect reward script. We add it here. Let's say it's going to give 100 experience points. Okay, now let's save this and give one last try. We're going to press play. Okay, we can play Unity here. Let's go to the snake. Apparently still another problem missing. Let's check what's here. We just have a problem with the current unit stats in the enemies, so well, let's try to move on here and see. Okay, so apparently we have another problem here. Let's try that again. Let's see if the battle scene looks good enough. Yes. Go back to the title, press play. Let's try another battle. So Apparently it worked now. Okay, so let's try again. We're going to press the attack button to kill that snake. We're going to kill the other one. We kill this one. So the time passes. Okay, we're able to destroy everyone and kill them. And if you look at your player units, you can see that they have received 50 experience points each. Okay, this happened because the enemy encounter had 100 experience points and it divided into two different players. Okay, so we can kill the snakes again and receive 50 more experience points. When this happens, both units are going to be holding 100 experience points. So the point here is to show you that the experience points amount is saved over time, okay? Because this player party can't be destroyed on load. Okay, so this should be it for this lesson. Okay, I hope you enjoyed this tutorial. We have covered lots of aspects here. Okay, we've talked about UI, we've talked about players and enemies, and what you can do is implement other enemies. If you look at the sprites folder in battle, you're going to see there are lots of things. You can add bats, dinos, dragons, and they could be much stronger enemies. Okay, reptiles, slimes. So there are many options for you to choose here. Implement new things, and also another interesting thing to implement is new maps. Okay, the town that we have here is just one scene, but you can make other scenes to further improve this game and have more challenges. You can purchase weapons. This is the basic building blocks for you to implement and make this game something huge. Okay, so this is it. Thank you very much for watching. My name is Glauco Pires, and I see you next time.